Ever wondered what powers the interactive elements on your favorite websites? The answer is a powerful scripting language known as JavaScript. This high-level interpreted programming language is primarily used for building dynamic and interactive web applications. The story of JavaScript begins in 1995, when Brendan Eich created it under the initial name of LiveScript. However, it soon underwent a rebranding, adopting the name JavaScript, which it proudly carries today. JavaScript's primary function lies in its use as a client-side scripting language in web browsers. It empowers developers to dynamically manipulate the content, structure, and behavior of web pages. From validating forms to creating animations and updating content without reloading the page, JavaScript is the magic behind these interactive features. One of the major advantages of JavaScript is its cross-platform compatibility. All major web browsers, including Chrome, Firefox, Safari, and Edge, support JavaScript. Moreover, it runs on various operating systems, making JavaScript a universal language for web development. JavaScript's nature as an interpreted language means that the code is executed line by line by a JavaScript engine in the browser. This approach allows for rapid development and testing as changes can be immediately seen in the browser. Being a high-level language, JavaScript is designed to be easily readable and writable by humans. It abstracts away low-level details, such as memory management, making it more accessible for developers. JavaScript is a multi-paradigm language that supports object-oriented programming concepts. It utilizes prototypal inheritance, where objects inherit properties and behaviors directly from other objects, a departure from traditional class-based inheritance. This scripting language also supports functional programming features. Functions can be treated as first-class citizens, including elements like higher-order functions, closures, and anonymous functions. The standardization of JavaScript is overseen by the ECMA International Organization through the ECMAScript specification. This specification defines the syntax, semantics, and behavior of JavaScript, ensuring consistency across different implementations. The ecosystem of JavaScript is vast and continuously expanding. It boasts libraries, frameworks, and tools that enhance its capabilities and simplify web development. From popular frameworks like React, Angular, and Vue.js for building large-scale web applications to libraries like jQuery for DOM manipulation and Ajax, JavaScript's ecosystem is a treasure trove for developers. With the advent of Node.js, JavaScript has broken free from the confines of the client-side and ventured into server-side development. Node.js allows developers to write server-side code using JavaScript, enabling full-stack JavaScript development. In conclusion, JavaScript plays a pivotal role in modern web development. It powers the interactivity and functionality of websites and web applications across the internet. Its versatility, ease of use, and extensive ecosystem have cemented its position as one of the most popular programming languages in the world.
Have you ever wondered about the history of JavaScript? Well, sit back and enjoy this enlightening journey of how JavaScript evolved from a simple scripting language to a powerful tool that drives modern web applications. Let's go back to the mid-1990s, when JavaScript was born at Netscape Communications Corporation. An engineer named Brendan Eich created it in 1995. Initially, it bore the name Mocha, then swiftly became LiveScript, before finally settling as JavaScript, presumably to ride the wave of Java's popularity. The world got its first taste of JavaScript in December 1995 with the release of Netscape Navigator 2.0. Its mission? To inject dynamism and interactivity into static web pages. As JavaScript's popularity surged, it was submitted to the European Computer Manufacturers Association, or ECMA, for standardization. The outcome was ECMAScript, the standardized specification for JavaScript, with its first edition published in 1997. Fast forward to the late 1990s and early 2000s, a period known as the browser wars. JavaScript was in the thick of it, with browser vendors adding proprietary features and extensions. This era also saw the emergence of the Document Object Model, or DOM, a standard for manipulating HTML and XML documents programmatically. It was during this time that frameworks like jQuery sprouted to solve cross-browser compatibility issues. Mid-2000s brought a resurgence for JavaScript with the advent of AJAX, short for Asynchronous JavaScript and XML. AJAX's ability to request and send data asynchronously without reloading the page revolutionized web application development, enabling a more responsive and interactive user experience. As we moved into the late 2000s and 2010s, JavaScript libraries and frameworks like AngularJS, React.js, and Vue.js mushroomed. These tools empowered developers to build complex single-page applications and manage application state efficiently. In 2009, Ryan Dahl introduced Node.js, a runtime environment that enabled server-side JavaScript execution. Node.js expanded JavaScript's reach to the backend, promoting the use of JavaScript for both client-side and server-side development. This convergence paved the way for isomorphic or universal JavaScript applications. From 2015, starting with ECMAScript 6, JavaScript underwent significant updates, introducing new language features like arrow functions, classes, modules, and more. Subsequent yearly ECMAScript releases continued to refine and enhance the language, ensuring its ongoing evolution and relevance. While JavaScript remains a dominant force in web development, newer technologies like WebAssembly or WASM are emerging to complement it. WASM allows high-performance, low-level programming languages like C, C++, and Rust to run in web browsers alongside JavaScript, opening up exciting new possibilities for web applications. And there you have it, a brief yet comprehensive journey through the history of JavaScript. From its humble beginnings at Netscape to its current role as a foundational web technology, JavaScript's evolution is a testament to its flexibility, resilience, and the vibrant community that continues to push its boundaries. Whether you're a seasoned developer or a curious onlooker, one thing is clear: JavaScript's story is far from over. It continues to evolve, adapt, and shape the future of web development.
JavaScript, the omnipresent language of the web, harnesses the power to breathe life into static web pages, transforming them into dynamic, interactive digital experiences. It's a language that's not only versatile, but also robust, making it a staple in the toolkit of many developers worldwide. Creating a JavaScript application involves a series of steps that, when followed meticulously, unravels the beauty of this language. Today we'll walk through these steps using a simple yet classic Hello World application. Firstly, we define a function. This function, aptly named sayHello, is set to perform one simple task: output Hello World to the console. The function is defined using the keyword function, followed by the name of the function, and then a set of parentheses. The code that the function will execute is placed within a set of curly braces. Output. The code inside our function is a console.log statement. Console.log is a method that JavaScript provides to print output. In this case, it prints the string "Hello World." With our function defined, it's time to call it into action. To do this, we simply write the name of the function followed by a set of parentheses. This command tells JavaScript to execute the code defined within the sayHello function. To bring this application to life, we need to run the code. Begin by opening a text editor, such as Notepad, Visual Studio Code, or Sublime Text. Copy the code into the text editor and save the file with a JS extension, for instance, hello.js. Next, open a terminal or command prompt and navigate to the directory where hello.js is saved. Here, type node hello.js and press enter. Voila! The words "Hello World" should appear in the console, signifying the successful execution of the JavaScript application. In summary, creating a JavaScript application involves defining and executing functions, using methods like console.log to print output, and saving and running the file using a text editor and a terminal or command prompt. This simple "Hello World" application is just the beginning. As you delve deeper into JavaScript, you can use its myriad features to create more complex, interactive applications. Remember, every journey starts with a single step, and you've just taken yours into the world of JavaScript.
Ever pondered the intricacies of variables in JavaScript? These fundamental building blocks of coding have more layers than you might think. To start, a variable is a container holding a value, which can be altered or updated throughout the execution of the program. Variables in JavaScript are dynamically typed, meaning you can assign values of different types to the same variable. If you're looking to declare a variable, you've got three keywords at your disposal: var, let, or const. Once upon a time, var was the go-to for variable declaration. However, it has some quirks and is less commonly used today. On the other hand, let and const, both introduced in ECMAScript 6, have risen in prominence. Let is your best bet for block-scoped variables that can be reassigned. Const, on the other hand, is perfect for declaring constants, variables whose value can't be changed once assigned. When it comes to syntax, it's as simple as let myvar equal sign hello for mutable variables or const myvar equal sign hello for constants. There are a few rules to keep in mind when naming your variable. They must start with a letter, $, or underscore, and subsequent characters can be letters, digits, $, or underscores. Remember, JavaScript is case-sensitive, so myvar, and myvar are all considered different variables. JavaScript variables can hold a variety of data types. There are primitive data types such as numbers, strings, booleans, null, undefined, and symbol. There are also complex data types like objects, arrays, and functions. Now on to scope. Variables declared outside of any function have a global scope, meaning they can be accessed from anywhere in your code. However, variables declared within a function have a local scope, meaning they are only accessible within that function. Another concept to get your head around is hoisting. In JavaScript, variable declarations are hoisted to the top of their containing scope during the compilation phase. But remember, only the declaration is hoisted, not the initialization. A few best practices to keep in mind. Use let or const instead of var to declare variables. Use meaningful variable names to enhance code readability. Declare variables close to where they are used. And use const for variables that should not be reassigned. So that's your crash course in JavaScript variables. Remember these key points. Variables are containers for values. They can be declared using var, let, or const, and they can hold various types of data. Variables have scope, and their declarations are hoisted during the compilation phase. Keep these concepts in mind, and you'll be writing cleaner, more efficient code in no time.
Have you ever wondered how JavaScript performs operations on data? Well, it's all about operators and expressions. These are fundamental concepts that allow us to manipulate and evaluate data in our scripts. First, let's talk about operators. These are special symbols that perform operations on operands. Take arithmetic operators, for example. They carry out operations like addition, subtraction, multiplication, and division. Think of a statement like result equals 10 plus 5. Here, plus is the operator performing the addition operation on the operands 10 and 5. But what about assigning values to variables? That's where assignment operators come in. They allow us to set and update values. An example would be x equals 5 or x plus equals 3, which is a shorthand way of saying x equals x plus 3. Moving on to comparison operators. These come into play when we need to compare two values. They return a Boolean result, meaning either true or false. For instance, 5 strictly equals 5 would return true, as would 10 is greater than 5. Logical operators also return a Boolean result, but they perform logical operations like and, and not. For instance, true and false returns false, while true or false gives us true. Then we have unary operators. These are operators that only take a single operand. For example, incrementing a variable x by writing x plus plus or decrementing it by writing x. There's also a special one called the ternary or conditional operator. It's a shorthand for an if-else statement. For example, is 5 greater than 3? If yes, return yes, else return no. Lastly, we have bitwise operators that perform operations on the binary representations of numbers, like 5 and 3 or 5 or 3. Now let's shift gears and talk about expressions. These are combinations of operators, operands, and variables that evaluate to a single value. Arithmetic expressions perform mathematical calculations like 5 times 2 plus 10 divided by 2. Logical expressions evaluate to a Boolean value based on logical operations. For instance, true and false or true and true would return true. Conditional expressions like the ternary operator we talked about earlier evaluate to a value based on a condition. Assignment expressions assign a value to a variable, like x equals 5 or x plus equals 3. Function call expressions call a function and evaluate to the return value of that function. For example, calling an add function with 3 and 5 as arguments. And finally, array and object expressions create arrays or objects. like declaring an array with 1, 2, 3 as elements, or an object with name and age properties. So, to wrap up, operators and expressions are the building blocks of JavaScript programming. They are essential for writing algorithms, conditions, and calculations. Understanding how to use them effectively is key to writing concise and efficient code. So keep practicing and exploring these concepts, and you'll soon find yourself writing JavaScript like a pro.
Ever wondered how developers control the execution flow of their code? Well, it's all about control flow and loop constructs. So grab a cup of coffee and get comfortable, because we're about to delve into the world of JavaScript control flow and loops. Firstly, we have conditional statements, which are the bread and butter of control flow in JavaScript. These are if-else statements. They allow code to execute based on whether a certain condition is met. For example, consider a variable x set to 10. An if-else statement can be used to check if ax is greater than 5. If true, a message is logged to the console. If not, a different message is logged. Next up is the switch statement, which evaluates an expression and executes code based on matching cases. Think of it as a more streamlined multiple-choice version of the if-else statement. To illustrate, let's consider a variable fruit set to apple. A switch statement can be used to check the value of fruit and log a corresponding message to the console. Output. Now, let's dive into loops, starting with the for loop. This loop is used to execute code repeatedly for a specified number of iterations. The loop initiates a counter, checks if the counter meets a specified condition, and then increments the counter after each iteration. Then there's the while loop, which executes a block of code as long as a specified condition is true. Unlike the for loop, the while loop only needs the condition, and the counter can be incremented within the loop. Closely related to the while loop is the do-while loop. This loop will always execute the block of code at least once before checking the condition, ensuring that the code runs even if the condition is not met on the first check. Onto the for ... in quote loop. This loop iterates over the innumerable properties of an object. For example, given an object person with properties name, age, and gender, a for ... in quote loop can be used to log each property and its value. Finally, we have the for of loop, which iterates over iterable objects such as arrays, strings, and collections. For instance, given an array colors, a for of loop can be used to log each color in the array. So there we have it, a tour through the landscape of control flow and loops in JavaScript. These constructs are the building blocks that help developers structure code, make decisions, and perform repetitive tasks efficiently. By understanding and mastering these concepts, you can write more efficient and organized code for a wide range of applications. Remember, conditional statements like if, else, and switch guide your code's decision-making process, while loops like for, while, do while, for ... in quote comma, and for ... of automate repetitive tasks. Keep practicing, and you'll be a JavaScript control flow and loop expert in no time.
Have you ever pondered over the process of decision-making in programming? It's all about making choices and taking different actions based on different conditions. Today, we'll be delving into the heart of this process, exploring the if-else statement in JavaScript. In the world of JavaScript, the if-else statement is a fundamental control flow statement. It's the pivot point where code can take different directions. It's like a crossroads, where the path chosen depends on certain conditions. At its core, the if and else statement is pretty straightforward. It evaluates a condition to either true or false, and executes different blocks of code accordingly. Imagine it as a question. Is this condition true? If the answer is yes, then JavaScript will execute a certain block of code. If the answer is no, then it will execute a different block of code. Here's how it looks in terms of syntax. In JavaScript, you'd write if, followed by a condition in parentheses. After that, you open a code block with curly braces. This block of code will be executed if the condition is true. But what if the condition is not true? That's where the else part comes in. You'd write else, followed by another code block. This block of code will be executed if the condition is false. So the if else statement is like a fork in the road with two paths. The condition determines which path to follow. But what if there's more than one condition to consider? This is where else if comes in. You can add as many else if blocks as you need after the initial if statement. Each else if block has its own condition and its own code block. If the first condition is false, JavaScript will check the next condition in the else if block. If that condition is true, it will execute the corresponding code block. If it's also false, it will move on to the next else if block, and so on. If none of the conditions in the if or else if blocks are true, then JavaScript will execute the code block in the final else section. Take this example. Suppose you have a variable named hour, which holds the current hour of the day. You want to display different greetings based on the time of day. You'd write an if statement to check if the hour is less than 12. If it is, you'd output a good morning message. If the hour is not less than 12, you'd use an else if statement to check if it's less than 18. If it is, you'd output a good afternoon message. If neither of these conditions are true, then you'd use an else statement to output a good evening message. So, to summarize, the if-else statement in JavaScript is a powerful tool for controlling the flow of your code. It allows you to execute different blocks of code based on different conditions. It starts with an if statement, can have one or more else-if blocks, and ends with an else block. The conditions are evaluated in order, and the first one that's true determines which block of code gets executed. Remember, the if-else statement is all about making decisions. It's a crucial part of programming, and understanding it will open up new possibilities in your coding journey. Ever found yourself in a tangled web of if, else statements while trying to manage multiple conditions in JavaScript? There's a handy tool in the JavaScript toolbox that can make your life a whole lot easier: the switch statement. Imagine the switch statement as a multilingual translator. You speak to this translator in one language, and it responds in the language that matches your input. In JavaScript, you provide an expression to the switch statement, and it executes the code block that matches the value of your expression. The basic syntax of a switch statement is as follows. You start with the keyword switch, followed by your expression in parentheses. This is your input to the translator. Then, you have a set of case statements within curly brackets. Each case represents a different language that the translator knows. If the value of your expression matches the value of a case, the code block following that case is executed. After the code block, we have a break statement. This is like telling the translator, "You've found the right language, no need to check the others." If you leave out the break, your translator will keep checking the remaining cases, even though it has already found a match. Finally, we have the default case. This is like the translator's response when it doesn't understand your language. If none of the case values match your expression, the code block under default is executed. Let's look at an example. Suppose we have a variable day with the value 3, and we want to find out the corresponding day of the week. We can use a switch statement to match day to the correct day name. If day is 1, day name becomes Sunday. If day is 2, day name becomes Monday, and so on, until we've covered all 7 days of the week. If day doesn't match any of our cases, we default to invalid day. After running this code, our console would display today is Tuesday, since day was 3. In summary, the switch statement in JavaScript is a powerful tool for managing multiple conditions. It starts with an expression, checks this against a series of cases, and executes the code block of the matching case. Don't forget to include a break after each case to prevent unnecessary checking of the remaining cases. And remember, if no cases match, the default case comes to the rescue. With the switch statement, managing multiple conditions becomes a much simpler task.
Ever wondered how a for loop works in JavaScript? Today we're diving deep into this fundamental coding concept. In the world of JavaScript, a for loop is akin to a workhorse. It tirelessly executes a block of code, repeating the process for a predetermined number of times. This construct, as versatile as it is dependable, comprises 3 optional parts. These are initialization, condition, and iteration. They're enclosed in parentheses and separated by semicolons, like a trio of code performing a synchronized dance. Let's examine the syntax. For initialization, condition, iteration. First, there's the initialization. Think of this as the starting point, the green light that sets the loop in motion. Typically, it's here that we initialize a counter variable. Next, we have the condition. This is the lifeblood of the loop. As long as this condition holds true, the loop keeps executing. If the loop encounters a false condition from the get-go, it won't execute at all. It's a strictly by-the-book operation. Finally, we have the iteration. This segment of the loop springs into action after each loop cycle. It often updates the counter variable or carries out other necessary operations. Now onto some examples. Consider a simple iteration from 0 to 4. For let I equals 0, I5 at plus plus. Here, let I equals 0 initializes the loop counter variable I at 0. I5 is the condition. As long as I is less than 5, the loop keeps going. I++ is the iteration incrementing I by 1 after each cycle. What about iterating over an array? Const array equals, for let I equals 0 array.length I++. Here, let I equals 0 again sets the counter variable I to 0. I.array.length is the condition. The loop continues as long as I is less than the length of the array. I+ increments I by 1 after each iteration, while array accesses each element of the array using the loop counter I. Lastly, let's look at nested loops. For let I, I3, I+. In this example, we have a nested for loop. The outer loop iterates over I from 0 to 2, and for each value of I, the inner loop iterates over j from 0 to 2, resulting in a total of 9 iterations. Output. In conclusion, a for loop in JavaScript is a key tool in any programmer's arsenal. Initialization sets the stage, condition dictates the duration, and iteration provides the progression. From simple iterations to complex nested loops, the for loop is a reliable workhorse, ready to take on any task. Remember, practice makes perfect. Happy coding!
Ever pondered the workings of while loops in JavaScript? Well, that's the puzzle we're aiming to solve today. A while loop in JavaScript is a core looping structure. It persistently executes a block of code as long as a specified condition evaluates to true. If, however, the condition is false from the outset, the loop will not execute even once. Here's how a while loop syntax looks in JavaScript. While condition, breaking it down, we have two key elements. First, the condition. This is the expression evaluated prior to each iteration. If the condition holds true, the loop runs. If it turns false, the loop ceases. Second, the code block. This is the code enclosed within the curly braces that will be executed again and again as long as the condition remains true. Output. Let's walk through a few examples. Example 1. A simple while loop. Imagine we have a variable I initialized to 0. We want to print its value as long as it is less than 5. For each iteration, we increment I by 1. The loop ceases when I is no longer less than 5. Output. Example 2. Processing user input with a while loop. In this scenario, we have a loop that runs indefinitely until the user enters a number greater than 10. Once the condition is met, the loop breaks. Example 3. A while loop iterating over an array. In this instance, we're using a while loop to iterate over an array of fruits. The loop continues as long as our counter I is less than the length of the array. Inside the loop, we access each element of the array using I and then increment I after each iteration. Output. In conclusion, while loops in JavaScript provide a powerful way to repeatedly execute a block of code based on a condition, these loops are fundamental to programming in JavaScript, and understanding them can significantly enhance your coding skills. Remember, the syntax is simple: a while keyword, a condition within parentheses, and a block of code within curly braces. The loop will continue to run as long as the condition remains true. And that's the magic of while loops in JavaScript. So, go ahead and experiment with these loops and unlock new programming possibilities.
Ever wondered how a do-while loop works in JavaScript? It's a fascinating concept that takes the while loop up a notch. First things first, let's demystify the do-while loop. It's eerily similar to the while loop, but it comes with a surprise. The do-while loop will always execute its code block at least once, even if the condition is initially false. After the first iteration, it simply carries on as long as the specified condition remains true. The syntax of a do-while loop It's a piece of cake. Imagine a JavaScript code like this. Do while condition. There are two main components here. First, the code block. This is the chunk of code enclosed in curly braces that will be executed at least once, no matter what the condition is. Second, the condition. It's the expression that is evaluated after each run. If the condition turns out to be true, the loop keeps going. But if it results in false, the loop calls it a day. Output. Here are some examples to make things crystal clear. In the first example, a simple do while loop is used. It starts with a variable I set to 0. The loop goes on printing the value of I and incrementing it by 1, as long as I is less than 5. In the second example, a do while loop processes user input. The loop continues to prompt the user for a number greater than 10. If the user obliges, it thanks the user. If the user doesn't, it asks again. In the third example, a do while loop is used to iterate over an array of fruits. The loop continues as long as the counter is less than the length of the array. Inside the loop, each element of the array is accessed using the loop counter, and then the counter is incremented after each iteration. Output. So, what's the takeaway? The do while loop in JavaScript is a versatile tool. It always runs its code block at least once and then continues as long as the condition is true. It's perfect for situations where you need to process or iterate over data until a specific condition is met. It's a simple yet powerful concept that can take your JavaScript coding to new heights. Keep experimenting, keep learning, and you'll master the do while loop in no time.
Ever wondered how to iterate over an object's properties in JavaScript? It's simpler than you might think, thanks to a handy tool called the for-in loop. It's a powerful feature of JavaScript that allows you to traverse all innumerable properties of an object. And yes, that includes properties inherited from its prototype chain. The for-in loop shines brightest when working with objects, as it iterates over keys or property names rather than values. Here's how the syntax looks. For variable in object. Don't get lost in the syntax. The variable is a placeholder that represents a different property name or key in each iteration. The object, on the other hand, is the object you're iterating over. Now, let's put theory into practice. Imagine we have a simple object, person, with properties name, age, and city. Const person equals sign. We can use a for-in loop to iterate over person like so. For let key in person. In this scenario, key represents the property name in each iteration, and person accesses the value associated with the current property in the person object. It's important to note a few things about the for-in loop. First, the order in which properties return is not guaranteed. It can vary across different JavaScript engines and runtime environments. Second, while you can use for-in loops to iterate over arrays, it can produce unexpected results. This is due to the enumeration over array indices and inherited properties. So when dealing with arrays, it's safer to stick with a for loop or the ForEach method. Here's a quick example of how a for-in loop would work with an array. Const fruits equals sign, for, let index in fruits. But remember, when working with arrays in JavaScript, it's generally best practice to use methods like ForEach, map, filter, or reduce. So, to recap, the for-in loop is a powerful JavaScript feature that allows you to iterate over the keys or property names of an object. It's easy to use, flexible, and a great tool to have in your JavaScript toolkit. Just remember, when working with arrays, stick with methods like ForEach for predictable, reliable results. Happy coding?
Ever wrestled with the complexities of iterating over iterable objects in JavaScript? It can be a bit of a head-scratcher, right? Thankfully, JavaScript provides a neat little tool to help navigate this process. The for-of loop. To understand this, imagine a collection of items. It could be a string, an array, a map, a set, essentially anything that's iterable. The for-of loop is your ticket to smoothly iterate over these objects, element by element, without getting tangled up in indices or keys. So what does a for-of loop look like? Picture this. You write for followed by parentheses. Inside these parentheses, you declare a variable. This will represent the current element value as you loop through. Next, you write of. followed by your iterable object. Finally, you add curly braces, and within these you write the code block to be executed for each iteration. Consider a basket of fruits represented as an array: apple, banana, orange. You want to list out each fruit. Here's how a for of loop can help. You declare fruit as your variable and fruits as your iterable. Then you instruct the loop to console log each fruit. As a result, each fruit in your basket is printed out one by one. No need to deal with indices. No need to get your hands dirty. But what about other iterable objects? Say a string. Absolutely. A for of loop works there too. Take the string hello. Using a similar structure as before, each character of hello is output one by one. However, there's a caveat. The for of loop does not work with plain objects, those that aren't iterable. So, if you've got an object with properties you want to iterate over, it's time to switch gears and use a for in loop instead. In a nutshell, the for of loop is a nifty tool for dealing with collections of data where you're interested in values rather than their indices or keys. It's concise, it's straightforward, and it's ready to make your JavaScript journey a whole lot smoother. So next time you're faced with an iterable object, remember the for of loop. It's a game changer. Ever puzzled over the distinction between for in and for of loops in JavaScript? It's a common question, and today we're going to unravel this mystery. First off, the for in loop. This loop is used to iterate over the innumerable properties of an object, including those in the prototype chain. What this means is, if an object has properties that can be counted or listed out, the for in loop will go through each one of them. The syntax for this type of loop is for, variable in object. Here's an example for clarity. Consider an object with properties A, B, and C, each with their own values. Using the for in loop, we can iterate over each property or key, and log both the key and its corresponding value. The output would look something like this: A1, B2, C3. Now, let's shift gears and talk about the for of loop. This loop works a bit differently. Instead of iterating over properties of an object, it iterates over the values of iterable objects. Iterable objects include arrays, strings, maps, sets, and so on. The syntax for this type of loop is for, variable of iterable. To illustrate, consider an array of fruits: apple, banana, and orange. Using the for of loop, we can iterate over each fruit in the array and log it. The output in this case would be apple, banana, orange. In essence, the key difference between the two lies in what they iterate over. The for in loop is all about the keys or property names of an object. It's like a locksmith going through a bunch of keys, checking each one. On the other hand, the for of loop is concerned with the values of an iterable object. It's more like a fruit vendor going through their stock, checking each fruit. So next time you're writing a loop in JavaScript, remember, use for in when you need to iterate over properties of an object, and for of when you want to go through the values of an iterable object. Happy coding.
Ever pondered about the role of functions in JavaScript, or how they work? Well, today we're diving into the world of JavaScript functions. Functions in JavaScript are reusable blocks of code designed to perform a specific task. Think of them as mini programs within your program, each with a unique job. They are fundamental to JavaScript and are even treated as first-class citizens. This means they can be assigned to variables, passed as arguments to other functions, returned from other functions, and more. The first type of function is the function declaration. This is the most straightforward type. You declare a function using the function keyword, followed by the name of the function and any parameters it needs. The code that the function executes is then placed within curly braces. Next, we have function expressions. This involves assigning a function to a variable. The function can be named or anonymous, but it's typically anonymous when used in a function expression. Arrow function expressions are similar to function expressions, but they use an arrow =, instead of the function keyword. This is a more compact syntax introduced in ES6, the 6th edition of JavaScript. Then we have anonymous functions, which are simply functions without a name. They are often used as arguments to other functions or as immediately invoked function expressions. When a function is declared, it can specify parameters which act like placeholders for values that will be used when the function is called. The actual values passed in when calling the function are called arguments. Functions can also return values using the return statement. If a function does not explicitly return a value, it returns undefined by default. To run or invoke a function, we use parentheses. It's also important to note that functions have their own scope. Variables declared inside a function are localized to that function and are not accessible from outside, unless they are explicitly returned or leaked into an outer scope. Lastly, we have closures. This is a complex but powerful concept in JavaScript. Functions form closures, meaning they can access variables in their outer scope even after the outer function has finished executing. To sum up, functions are incredibly versatile and essential tools in JavaScript. They help structure code, enable code reuse, and allow us to implement complex logic. So next time you're working with JavaScript, remember the power of functions and use them to your advantage.
Ever wondered what named functions in JavaScript are and why they're so significant? Well, today we delve into the intricate world of JavaScript functions. Named functions, to be precise. Imagine you're a detective trying to solve a mystery. Named functions in JavaScript are like the clues to your case. They're functions declared with a specific name. You create them using the function keyword followed by the name of the function. Sounds simple, right? But there's more to it than just that. Let's start with function declarations. It's like declaring your intentions to solve the case. In JavaScript, the function name is declared as a variable in the current scope. For instance, consider this code, function add_a_b. Here you've declared a function named add. You can call this function using its name. For example, you could write console log add23, and the output would be 5. Moving on to function expressions, where things get a bit more interesting. Function expressions involve assigning a function to a variable. Even in this scenario, the function can have a name. Take a look at this example. var multiply =, function multiply ab. Here, the function is called using the variable name. So, console log multiply 2, 3 would output 6. Now you may ask, why even bother with named functions? Well, they come with some compelling benefits. Firstly, they provide a meaningful name to the function, which improves code readability and maintainability. Secondly, they can be called recursively within their own scope. Lastly, they facilitate debugging. The name of the function appears in stack traces, making it easier to trace back where an error occurred. But remember, function expressions with names are optional. You can have anonymous function expressions. For example, var greet =, function name, bah. Here, the function is anonymous as it doesn't have a name. Named functions come in handy when you need to reference the function within its own body, or when you want more descriptive stack traces for debugging purposes. So there you have it, a detailed yet simplified explanation of named functions in JavaScript. From function declarations to function expressions, we've covered it all. Remember, just like a good detective, a good programmer also knows the importance of each function and how to use it effectively. Until next time, keep coding.
Ever pondered the nature of an anonymous function in JavaScript? It's a function declared without any identifier, or in simpler terms, without a name. Usually, it's defined using the function keyword, or as an arrow function, but without assigning it a name. Imagine declaring an anonymous function using the function keyword. It might look something like this. An anonymous function is created and assigned to a variable named anonymous function. When this function is called, it will output the text. This is an anonymous function. Now consider an example using an arrow function. The anonymous function is created and assigned to a variable named anonymous arrow function. When this function is called, it will output the text. This is an anonymous arrow function. Output. Anonymous functions often come into play in scenarios where a function is required for immediate use, or where a function is passed as an argument to another function, also known as callback functions. They are also used in IIFEs, or immediately invoked function expressions, to encapsulate code blocks and avoid polluting the global scope. Consider a situation where a function is needed temporarily or as a callback. Anonymous functions are commonly used as callback functions in event handlers, or as arguments to functions like ForEach, map, filter, and so on. Imagine a collection of numbers, say 1 through 5. Now consider using an anonymous function as a callback. A variable named numbers holds an array of numbers from 1 to 5. The ForEach method is called on this array, with an anonymous function passed as a callback. This function takes a number as an argument and outputs that number multiplied by 2. The anonymous function is executed for each element in the numbers array, in this case, outputting each number of the array multiplied by 2. Output. To sum up, anonymous functions are a versatile and essential part of JavaScript. They are functions declared without a name, often used for immediate execution or as callback functions. They can be declared using the function keyword or as arrow functions, and are a common feature in scenarios requiring temporary functions or encapsulated code blocks to avoid polluting the global scope. Whether you're dealing with event handlers, array methods, or IIFEs, anonymous functions are a fundamental tool in your JavaScript toolkit.
Ever wondered about the sleek, concise syntax of arrow functions in ES6? It's a game changer in JavaScript, and today we're delving deep into its intricacies. In the realm of JavaScript, arrow functions, a feature introduced in ECMAScript 6 or ES6, offer a more condensed syntax for creating functions. Their primary advantage shines through when crafting short inline functions. Imagine you're writing a function to add 2 numbers. In standard JavaScript, you would define it using the function keyword. With arrow functions, you'll use the arrow equals sign syntax. Here's how it works. You write const add equals, then your parameters in parentheses, in this case a and b. After that, you put your fat arrow equal sign, and then your function body in curly braces. Inside, you'd write return a plus b. But arrow functions can be even more concise. If your function body consists of only one expression, you can drop the curly braces and the return keyword. The result of your expression will automatically be returned. So our add function becomes const add equals ab arrow a plus b. In an even more condensed form, if your function has just one parameter, you can drop the parentheses around the parameter list. So a function to square a number, x, would be const square equals x arrow x times x. Now let's talk about this. Arrow functions don't have their own this context. They inherit it from the surrounding code, which can be handy when working with object methods or event handlers. If you have an object, say person, with a method greet that sets a timeout, inside that timeout you can use this.name, and it will correctly refer to the name property of the person object. But there's a caveat. Arrow functions don't have their own arguments object. If you need to use function arguments, you'll have to use rest parameters, denoted by or what args. And finally, arrow functions can't be used as constructors with the new keyword. They lack the internal method necessary for creating instances. To sum it all up, arrow functions are a neat tool in ES6 for writing more concise JavaScript code, especially for simple inline functions. But they come with their own set of quirks like lexical scoping and the lack of certain features. Use them wisely, and they can make your code easier to read and write, but remember, with great power comes great responsibility. Happy coding.
Ever wondered what an immediately invoked function expression or an IIFE is in JavaScript? Well, you're about to find out. An IIFE is a function that is both defined and invoked immediately after its creation. Picture it as a self-contained bubble of code that executes on the spot and doesn't leave any trace in the global scope. How do we craft this little marvel? Let's break it down. Here's the basic structure of an IIFE. We start with an anonymous function expression enclosed within parentheses. This is what it looks like. Function. Oh, now what's going on here? Function. This part of the code is an anonymous function expression, nestled cozily within parentheses. The parentheses wrapping around the function declaration are the guardians that ensure the JavaScript parser treats it as a function expression, rather than a function declaration. The difference is crucial because function expressions can be invoked immediately, unlike function declarations. And what about those trailing parentheses, you ask? They're the magic dust that immediately invokes the function expression. This pair of parentheses at the end of the function expression makes sure the function is executed right after it's defined. scene script. But what can we do inside this IFE? Well, pretty much anything you can do in JavaScript. You can declare variables, define functions, and perform any JavaScript operations you need. Consider this example. Function var x = 10, console log inside IIFE x. In this case, x is a variable declared inside the IF. Its existence is limited to the scope of the IF. It's like a secret agent working undercover. Output. IIFEs have earned their place in JavaScript for a variety of reasons. They create private scopes, prevent naming collisions, and manage variable scope. However, with the advent of modern JavaScript features like block-scoped variables, let and const, and modules, the usage of IFEs has somewhat declined, but they still hold relevance in certain contexts. So to wrap things up, an immediately invoked function expression is a way to encapsulate code and avoid polluting the global scope in JavaScript. It's like a secret mission that executes instantly and leaves no trace behind. It's a powerful tool, and now you know how to wield it. Congratulations on adding another skill to your JavaScript arsenal.
Have you ever wondered how generator functions in JavaScript work, how they yield values, how they're declared, and how they're consumed? Well, today is your lucky day, because we'll be diving into the world of generator functions. Generator functions, introduced in ECMAScript 6, are special types of functions that allow you to pause and resume the execution of a function, yielding multiple values one at a time. So, how do we declare a generator function? It's simple. All you need to do is use the function asterisk syntax. Yes, you heard that right. There's an asterisk right after the function keyword. Here's an example. Imagine a function named myGenerator. It's a function that yields the numbers 1, 2, and 3 one at a time. Output. Every time you call the yield keyword inside this generator function, it pauses and emits a value. But how do we consume these yielded values? The answer lies in the iterator interface. Generator functions automatically return an iterator when you call them. You can either use a for of loop or explicitly call the iterator's next method to go over the yielded values. What's more, generator functions can produce an infinite sequence of values. Yes, they can yield values indefinitely using loops or recursion, but don't worry, you won't be stuck in an infinite loop. You can consume values from a generator until it's done, or if you want to stop early, you can break out of the loop. Even more fascinating is the fact you can send values to a generator. How? By using the generator.nextValue method. The value you send becomes the result of the yield expression where the generator is paused. So what's the takeaway from all this? Generator functions in JavaScript provide a flexible and concise way to define custom iterators and generate sequences of values lazily. This can be incredibly useful when dealing with large datasets or asynchronous operations. So, the next time you find yourself needing to generate a sequence of values in a controlled manner, remember, generator functions are your friends. They offer an elegant solution to pausing and resuming functions, yielding values one at a time and handling large, complex datasets with ease.
Ever wondered about the superpowers of JavaScript? One such superpower is its ability to handle higher-order functions. Now, what exactly are higher-order functions? Well, in JavaScript, higher-order functions are those that can take other functions as arguments, return functions as results, or even do both. This is an integral part of functional programming and allows for highly flexible and powerful code patterns. To kick things off, consider functions as arguments. In JavaScript, it's perfectly acceptable to pass functions as arguments to other functions. Here's a simple example. Imagine a function named higher-order function that takes another function, Callback, as an argument. This callback function is then invoked within the higher-order function. When higher-order function is called with callback function as its argument, the console logs callback function called. Output. Moving on to the second aspect of higher-order functions, functions as return values. In JavaScript, functions can be returned from other functions. For instance, higher-order function returns an anonymous function that logs returned function called when invoked. The returned function is stored in a variable returned function and is subsequently called to produce the output. Next, let's delve into some practical examples of higher-order functions with array methods like map, filter, and reduce. Consider an array of numbers. The map method is used to create a new array, doubled, where each number is doubled. The filter method, on the other hand, is used to create a new array, evens, consisting only of even numbers. Lastly, the reduce method is used to calculate the sum of all numbers in the array stored in the variable sum, output. Finally, a key concept to understand in the context of higher-order functions is closures. Closures allow inner functions to access variables from outer functions even after the outer function has finished executing. In the given example, the inner function accesses the outer variable from the outer function even after outer function has completed its execution. In conclusion, higher-order functions are incredibly powerful tools in JavaScript. They promote code reusability, modularity, and maintainability, especially when used in conjunction with functional programming paradigms. So next time you're writing JavaScript code, remember to harness the power of higher-order functions to keep your code clean, concise, and expressive.
Have you ever wondered how recursive functions work in JavaScript? The concept might seem a little daunting at first, but fear not. By the end of this video, you'll have a good grasp of what recursive functions are and how to use them effectively. IIFE. A recursive function is essentially a function that calls itself until a specific condition is met. It's like a dog chasing its tail, but with a purpose. The function keeps repeating itself until it achieves the desired result. This process is broken down into two main parts, the base case and the recursive case. The base case is like a safety net. It defines when the recursion should stop so that the function doesn't end up calling itself infinitely. On the other hand, the recursive case is where the function calls itself, but with a different input each time, inching closer to the base case with every iteration. Take the factorial function as an example. In mathematics, the factorial of a non-negative integer n is the product of all positive integers less than or equal to n. In JavaScript, this can be achieved with a recursive function like so. Function factorial n equals sign 1. Return an asterisk factorial 1. Console log factorial 5. / output 120. Here, the base case is when n equals 0 or 1 and the function returns 1. The recursive call happens when n is multiplied by the factorial of n-1. Output. With each recursive call, a new frame is added to the call stack. This is a storage space where JavaScript keeps track of all the function calls. Once the base case is reached, the stack starts to unwind, and each function call returns its result to the previous one. Sometimes, recursive functions may call other functions, which in turn call the original function again. This is known as indirect recursion. It's like passing the baton in a relay race, where each runner is a function, and the racetrack is the solution to the problem. There's also a concept called tail recursion, where the recursive call is the last operation performed by the function. However, it's important to note that JavaScript doesn't optimize for tail recursion, which means it can lead to a stack overflow error if the recursion depth is too large. And that brings us to a crucial cautionary note. Recursive functions can be elegant and powerful, but they can also be less efficient than iterative solutions for some problems, especially if the recursion depth is large. Therefore, it's essential to ensure that recursive functions have a well-defined base case and that they terminate within a reasonable number of iterations. In summary, recursive functions in JavaScript offer a unique and powerful way to solve problems that can be broken down into smaller, similar subproblems. But like any powerful tool, they need to be used with care and understanding. So go forth and recurse, but do it wisely.
Have you ever wondered how JavaScript handles asynchronous operations? Well, one way it does this is through something called callback functions. If you're scratching your head, don't worry. By the end of this video, you'll be able to understand what callback functions are and how they work in JavaScript. To start, it's important to know that in JavaScript, functions are first-class citizens. This means they can be passed around as arguments to other functions. A callback function, then, is a function that is passed as an argument to another function and is executed later. Consider this simple example. Here we have a callback function that is passed to the setTimeout function. The callback function greet is executed after a 1-second delay. The setTimeout function is an asynchronous operation, meaning it doesn't block the rest of the code from executing while it waits for the timer to finish. Now, callback functions are commonly used with asynchronous operations. These might include fetching data from a server, reading files, or handling user input. The callback function is executed once the asynchronous operation completes.
allowing you to handle the result or perform further actions. Here's an example of how you might use a callback function to handle data fetched from a server. In this case, the fetchData function fetches some data and then calls the callback function, passing the fetched data as an argument. The callback function, processData, then logs the received data. So what if you don't want to define your callback function separately? Well, you can define it inline as an anonymous function. Here's an example of how you might do that with the setTimeout function. In some instances, like in Node.js and some JavaScript libraries, it's common to pass callback functions with an error-first argument. This means that the first argument passed to the callback function is an error object, which will be null if no error occurred. In this example, we're simulating asynchronous file reading. The readFile function reads a file and then calls the callback function, passing an error object and the data as arguments. The callback function then checks if an error occurred and either logs the error or the data. To wrap it up, callback functions are a powerful tool for handling asynchronous operations in JavaScript. They allow you to execute code in response to events or upon completion of tasks, making them a key part of managing asynchronous behavior and implementing non-blocking code. So, the next time you're working with JavaScript, remember to consider using callback functions to handle your asynchronous operations. With practice, you'll find them to be an incredibly useful tool in your programming arsenal.
Objects in JavaScript are essentially collections of key-value pairs. Imagine them as a personal dictionary, where every word, the key, has a corresponding definition, the value. These keys are strings or symbols, and the values can be any data type, including other objects, arrays, or even functions. Objects are the go-to when dealing with complex data structures and entities in JavaScript applications. Creating an object is as simple as using curly braces with key-value pairs separated by colons. For example, consider an object person with properties like name, age, and address. The address property here is an object itself, demonstrating that objects can nest within objects. Accessing these properties is a breeze. You can use dot notation or bracket notation. For instance, to get the name of the person, we would write person.name, and voila, we have John. Output. Now, let's shift gears to arrays. Arrays are like a well-organized bookshelf, an ordered collection of values, each indexed by a numeric index starting from 0. Arrays are the perfect choice when you need to store lists of items, be it numbers, strings, objects, or other arrays. Creating an array is straightforward with square brackets and items separated by commas. For instance, an array numbers could hold a sequence of numeric values, and an array fruits could store a list of fruits. Accessing these elements is as easy as pie. We use square brackets and the index of the element. For example, numbers would give us the first number in our array. Arrays come equipped with a vast toolkit of built-in methods for manipulating their contents. From adding or removing elements to slicing and filtering them, arrays have got you covered. So, how do objects and arrays differ? While objects use named keys to access values, arrays use numeric indices. Objects are perfect for structured hierarchical data, while arrays are ideal for collections of similar items. An interesting difference is that arrays have a length property which indicates the number of elements in the array, while objects lack this property. In essence, objects and arrays are the building blocks of JavaScript. Mastering them is akin to mastering the language itself. They are versatile, widely used, and understanding them is crucial to effective JavaScript programming. Remember, objects are your personal dictionaries of key-value pairs, and arrays are your organized bookshelves of indexed values. Happy coding! Happy!
Ever pondered on how to manipulate arrays in JavaScript? Well, worry no more. Today, we will delve into some of the most commonly used array manipulation methods in JavaScript. First, let's discuss the push method. This method adds one or more elements to the end of an array and returns the new length of the array. For instance, imagine an array with elements 1, 2, 3. By using the push method and adding 4, the array becomes 1, 2, 3, 4. Now, let's move to the pop method. This method removes the last element from an array and returns that element. So, if you have an array with elements 1, 2, 3, and you use the pop method, the array becomes 1, 2, and the method returns the popped element, 3. Next up is the shift method. This method removes the first element from an array and returns that element. This operation changes the length of the array. For example, if you have an array with elements 1, 2, 3, and you use the shift method, it will return 1, and the array will become 2, 3. The unshift method is up next. This method adds one or more elements to the beginning of an array and returns the new length of the array. So if you have an array with elements 2, 3, and you use the unshift method to add 1, the array becomes 1, 2, 3. Let's talk about the slice method. This method returns a shallow copy of a portion of an array into a new array object selected from start to end, with the end not included. The original array will not be modified. For instance, if you have an array with elements 1, 2, 3, 4, 5, and you use the slice method to slice from index 1 to 4, it will return a new array with elements 2, 3, 4, and the original array remains unchanged. Lastly, we have the splice method. This method changes the contents of an array by removing or replacing existing elements and/or adding new elements in place. For example, if you have an array with elements 1, 2, 3, 4, 5, and you use the splice method to remove one element starting from index 2, the array becomes 1, 2, 4, 5. You can also use the splice method to insert elements at a particular index. If you insert A and B at index 2, the array becomes 1, 2, A, B, 4, 5, 4. In conclusion, these array methods are fundamental for manipulating arrays in JavaScript. They are widely used in various applications and are crucial tools in every JavaScript programmer's toolbox. So keep practicing, and soon, these methods will become second nature to you.
Ever wondered about the ForEach function in JavaScript? Its beauty lies in its simplicity and efficiency. Today, we're diving into the heart of this function, bit by bit, to uncover its potential. The ForEach function, a higher-order function in JavaScript, is a tool to traverse each element of an array. It's like an efficient tour guide, leading you through each item in the array without missing a single one. The function operates by executing a callback function for each element in the array. This callback function can do anything you want with each array element, giving you a lot of flexibility. The syntax of the ForEach function is quite straightforward. Imagine you're commanding an array to perform a specific task for each of its elements. In JavaScript code, it would look like this: Array.forEach callback current value index / code block to be executed. Here, callback is the task you're asking to be performed. It's a function you provide to be executed for each element in the array. The current value is the array element currently being processed. Think of it as the individual item in the array that the callback function is currently working with. Optionally, you can also include index, which represents the position of the current value in the array. Another optional parameter is the array itself, which is the array that the ForEach function was called upon. One key point to remember is that the ForEach function does not mutate the original array. It's like a considerate guest, leaving everything as it was found. Let's illuminate this concept with an example. Suppose we have an array of numbers. We can use the ForEach function to log each element and its index to the console. The code would look like this: const numbers = sign, numbers, ForEach function, item, index, console.log. This would output each element and its index starting from 0, like so. Element at index 0 is, 1 element at index 1 is, 2 element at index 2 is, 3 element at index 3 is, 4 element at index 4 is, 5. In this example, the ForEach function is taking a tour of each element in the numbers array. For each stop on the tour, it executes the callback function, logging the element and its index to the console. To summarize, the ForEach function in JavaScript is a powerful tool for iterating over array elements. It's simple yet flexible, allowing you to define exactly what operation to perform on each array element. And importantly, it respects the original array by not mutating it. So, when coding in JavaScript, Remember to take advantage of this efficient tour guide through your arrays.
Have you ever wondered how JavaScript's object-oriented programming model works? Today we're diving into the intriguing world of JavaScript prototypes. Let's begin with the prototype chain. In JavaScript, this prototype-based language allows objects to inherit properties and methods directly from other objects. This inheritance is established through the prototype chain. Each object has an internal property known as prototype, which points to another object. When you access a property or method on an object, JavaScript first checks if the object itself has that property or method. If it doesn't, it looks at the object's prototype and continues this chain until it finds the property or method or reaches the end. Now let's talk about the prototype property. In JavaScript, constructor functions have a property called prototype. This property isn't the prototype of the constructor function itself, but rather the prototype that will be assigned to instances created with that constructor function using the new keyword. By attaching properties and methods to this prototype object, they will be inherited by all instances created from the constructor function. For instance, consider a person function with the name property. Now, if you attach a sayHello method to person's prototype and create two instances, person1 and person2, with names Alice and Bob respectively, both these instances will have access to the sayHello method. Next on the list is the Object.createCar method. This method creates a new object with the specified prototype object and optional properties. It allows you to create objects with specific prototypes without using constructor functions. For instance, if you create a person prototype with a sayHello method and use Object.create to create a new person with the name Charlie, this new person will have access to the sayHello method. There's also the property. Though not recommended for direct use due to being non-standard, the property provides direct access to an object's prototype. It can be used to get or set the prototype of an object. For example, if you have a cat object with a sound property and a kitten object with a color property, you can set the kitten's prototype to be the cat, giving the kitten access to the cat's sound property. Lastly, we have the Object.getPrototypeOf and Object.setPrototypeOf methods. The Object.getPrototypeOf method returns the prototype of a specified object, while Object.setPrototypeOf sets the prototype of a specified object to another object. For example, if you have a person object with a name property and a person prototype with a sayHello method, you can set the person's prototype to be the person prototype, giving the person access to the sayHello method. Understanding prototypes is essential for effectively utilizing JavaScript's object-oriented features and for mastering advanced concepts like inheritance and polymorphism in the language. So, remember, prototypes are a fundamental concept in JavaScript that form the basis of the language's object-oriented programming model. They're the secret sauce that makes JavaScript such a powerful and flexible language. Now go forth and code with confidence in your new understanding of JavaScript prototypes.
Have you ever wondered how inheritance works in JavaScript? Well, it's a key concept in object-oriented programming that allows objects to inherit properties and methods from other objects. There are several ways to implement inheritance in JavaScript, and today we're diving into each one of them. The first method is what is known as the prototype chain. JavaScript uses a prototype-based inheritance model. Each object in JavaScript has a prototype property which points to another object. When a property or method is accessed on an object, JavaScript first looks for it directly on the object. If it's not found, it continues to look for it on the object's prototype and so on, forming a chain called the prototype chain. Consider the following example. We have a function called animal that takes a name as a parameter. Then we define a method on the animal prototype called sayName. We also have a function called dog that calls the animal function with its own context and a breed parameter. We then set the dog prototype to be an object created from the animal prototype and set the constructor to dog. We also define a bark method on the dog prototype. When we create a new instance of dog and call the sayName and bark methods, it works as expected because of the prototype chain. The second method of implementing inheritance in JavaScript is through constructor inheritance. In this approach, constructor functions are used to create objects with shared properties and methods. Child constructor functions call the parent constructor using call or apply, passing their own context, and then may define additional properties and methods. However, this approach has a pitfall. If we follow the same example as above, but without setting the dog prototype to an instance of animal, calling sayName on an instance of dog would throw an error because dog prototype does not inherit from animal prototype. This issue can be fixed by setting dog prototype to a new instance of animal. The third method is the ES6 class syntax. ES6 introduced class syntax, which provides a more familiar way to work with inheritance in JavaScript. Classes encapsulate prototype-based inheritance under the hood, but the syntax is more similar to classical object-oriented languages like Java or C++. In our example, we define an animal class with a constructor and a sayName method, and a dog class that extends animal. It also has a constructor that calls the parent constructor with super, and defines a new method called bark. When we create a new instance of dog and call sayName and bark, it works as expected because under the hood, it's still using prototype-based inheritance. So, there you have it. 3 methods of implementing inheritance in JavaScript: prototype chain, constructor inheritance, and ES6 class syntax. Each has its own strengths and weaknesses, but all are powerful tools to create more efficient and maintainable code. Understanding them will unlock a deeper understanding of JavaScript and its object-oriented capabilities.
Have you ever wondered how JavaScript handles asynchronous operations? It's a fascinating process that unfolds behind the scenes, making your code run smoothly and efficiently. Firstly, JavaScript uses a mechanism known as callbacks. Picture this, a function nestled within another function, waiting for its moment to shine. This inner function is the callback function, passed as an argument to the outer function. It bides its time, only springing into action when the outer function completes its operation. Imagine a code snippet. Here, fetchData is a function that takes a callback as an argument. It uses a setTimeout function to simulate an asynchronous operation. When the operation completes after 1000 milliseconds, the callback function is invoked with the message, "Data fetched successfully." When fetchData is called with a callback function that logs the result, the message is printed to the console after the delay. But there's more to asynchronous JavaScript than callbacks. Enter promises. Promises are like well-mannered children. They promise to do something, and they won't rest until they've done it. A promise represents the eventual completion or failure of an asynchronous operation and allows for the chaining of such operations. In a typical scenario, fetchData returns a new promise. This promise is resolved after 1000 milliseconds with the message, "Data fetched successfully." When fetchData is called, it returns a promise. The then method is then used to register a callback that is invoked when the promise is resolved. If there's an error, the catch method is used to handle it. Yet, the sophistication of asynchronous JavaScript doesn't end there. With the introduction of ES8 or ECMAScript 2017 came async await, a syntactical feature that makes asynchronous code look and behave like synchronous code. It's built on top of promises and provides an even cleaner way to handle asynchronous operations and errors. Consider an example where fetchData is an asynchronous function that returns a promise. FetchData and process is another asynchronous function that calls fetchData using the await keyword. The await keyword makes JavaScript pause and wait for the promise to resolve or reject, then resumes the execution and returns the resolved value. Lastly, we have the event loop. Remember, JavaScript is single-threaded, which means it can execute only one piece of code at a time. But how does it handle multiple asynchronous operations concurrently without blocking the main thread? It uses an event-driven model with an event loop. The event loop continuously checks for tasks in the task queue and executes them when the call stack is empty. In summary, JavaScript's handling of asynchronous operations is a symphony of callbacks, promises, async, await, and the event loop. Together, these mechanisms enable JavaScript to run asynchronous code efficiently, making your web applications more responsive and user-friendly. So the next time you see an asynchronous operation in JavaScript, you'll know the magic that's happening behind the scenes.
Have you ever wondered how to handle asynchronous operations in JavaScript? Well, the answer lies in a concept called promises. Promises are like a beacon in the stormy sea of asynchronous JavaScript, guiding you towards cleaner and more structured code. So, what exactly is a promise? In JavaScript, a promise is an object that represents the eventual outcome of an asynchronous operation. It could either be a successful completion or a failure, each with its resulting value. Promises can exist in 3 states. The pending state is the initial status of a promise, indicating that the asynchronous operation is still in progress. Then there's the fulfilled or resolved state, which signifies a successful completion of the operation, and finally the rejected state, which occurs when the operation fails. Now, how do you create a promise? You can do so by using the promise constructor. This constructor accepts a function, commonly known as the executor, as an argument. The executor function in turn takes 2 arguments, resolve and reject. The resolve is called when the operation is successful, and the reject is called when it fails. Once a promise is created, you can consume it using the then method for a successful resolution and the catch method for a rejection. This way you can handle both the outcomes of an asynchronous operation. But what if you want to execute multiple asynchronous operations sequentially? That's where the power of chaining promises comes into play. You can simply chain them together using the then method. Now, if you're looking for a cleaner syntax to work with promises, ES8 introduced the async and await keywords. The async keyword marks a function as asynchronous, while the await keyword pauses the execution of an async function until a promise is resolved. To sum it all up, promises in JavaScript are a powerful tool that offer a structured approach to handle asynchronous operations. They improve code readability, especially when dealing with complex operations. So, the next time you're diving into the ocean of asynchronous JavaScript, remember to take promises along. They'll be your lifebuoy, ensuring you don't get lost in the waves of callbacks.
Ever wondered how JavaScript manages asynchronous operations? Well, the key lies in a process called the event loop. Let's delve into it. JavaScript is single-threaded, which essentially means it can only execute one piece of code at a time. This might sound limiting, but it's not. Unlike languages such as Java or Python, which support multi-threading, JavaScript has a unique way of handling tasks. JavaScript employs asynchronous operations to manage I/O tasks. This could be anything from fetching data from a server to reading files. When such an operation is initiated, JavaScript doesn't twiddle its thumbs waiting for it to complete. Instead, it moves on, executing other pieces of code while waiting for the operation to finish. This non-blocking nature of JavaScript ensures the program doesn't come to a standstill while waiting for I/O operations to complete. Now, how does JavaScript manage all these tasks? Enter the event loop. This is a mechanism that constantly checks the call stack and the task queue. Let's break it down. The call stack is a tracking system maintained by JavaScript. It keeps tabs on the currently executing function calls. When a function is called, it's as if it's pushed onto a stack. When it completes, it's popped off the stack. Then we have the task queue. This is a storage system for tasks ready to be executed. These tasks often include callback functions from asynchronous operations, such as timer callbacks, I/O callbacks, or even events like a click or a key press. The event loop is the maestro here, orchestrating this dance between the call stack and the task queue. If the call stack is empty, the event loop takes the first task from the task queue and pushes it onto the call stack for execution. This process continues indefinitely, ensuring that asynchronous tasks are executed in the order they were queued. Consider this piece of JavaScript code as an example. The start and end are logged synchronously, as they're part of the main execution flow. The set timeout and promise resolve, then, are asynchronous operations. They are placed in the task queue when encountered, and their callbacks are executed once the call stack is empty. Understanding the event loop is pivotal for writing efficient asynchronous JavaScript code. It empowers developers to effectively harness non-blocking I/O operations, creating applications that are responsive and efficient. So the next time you're working on your JavaScript code, remember the event loop, the unsung hero making all your asynchronous operations possible.
Ever pondered about how web pages are dynamically updated? The secret lies within the fascinating world of DOM, the document object model, and its manipulation using JavaScript. The document object model, or the DOM, is the structure of a web page represented as a tree-like structure, with each element being a node in the tree. JavaScript, a powerful tool in web development, provides APIs for accessing, creating, modifying, and deleting elements within the DOM. So, how does DOM manipulation work? Let's delve into it step by step. Firstly, accessing elements. JavaScript offers various methods to access elements in the DOM, such as getElementById, getElementsByClassName, getElementsByTagName, querySelector, and querySelectorAll. These methods fetch elements based on their ID, class name, tag name, or a query. Next, we move on to modifying elements. Once an element is accessed, its properties, attributes, and content can be modified. This can be achieved by changing the text content, HTML content, CSS styles, or attributes using JavaScript. Thirdly, there's creating elements. JavaScript allows you to dynamically create new elements and append them to the DOM. This involves creating a new element, setting its properties, and appending it to the DOM. Event handling is another significant aspect of DOM manipulation. Event listeners can be attached to DOM elements to handle user interactions such as clicks, key presses, mouse movements, and more. Lastly, we have removing elements. Elements can be removed from the DOM using the removeChild method. In conclusion, DOM manipulation is a potent feature of JavaScript that enables dynamic changes to the content and structure of web pages. When combined with event handling, it can create interactive and dynamic web applications. However, remember to use DOM manipulation judiciously to ensure performance and maintainability of your code. It's a powerful tool in your toolbox, but like all tools, it must be used wisely. And with that, we have traversed the landscape of DOM manipulation. From accessing elements to removing them, each step carries its own importance in dynamically updating web pages. Remember these key points and continue to explore the vast, fascinating world of JavaScript and DOM manipulation.
Ever wondered how to access elements in JavaScript? Well, you're not alone. It's a common question, and today we're going to shed some light on it. There are several ways to access elements in JavaScript, depending on the type of element and the context in which you're working. Let's start with a method called getElementById. This method retrieves an element by its ID attribute. Consider this piece of code: var element $document.getElementById myElementId. Here, the element with the ID myElementId is being accessed and stored in the variable element. Next up, we have getElementsByClassName. This method retrieves elements by their class name. However, unlike getElementById, this method returns a collection of elements. Look at this example: var elements $document.getElementsByClassName myClassName. This code fetches all elements with the class name myClassName. Moving on, we encounter getElementsByTagName. This method retrieves elements by their tag name, and similar to getElementsByClassName, it returns a collection. Here's an example: var elements $document.getElementsByTagName div. This code fetches all div elements present in the document. Now let's talk about querySelector. This method allows you to select a single element using CSS selectors. Take a look at this code: var element $document.querySelector #myElementId. This line of code fetches the element with the ID myElementId. Then there's querySelectorAll, which works similarly to querySelector, but it returns a collection of elements matching the selector. An example would be var elements $document.querySelectorAll myClassName. This code fetches all elements with the class name myClassName. Once you have a reference to an element, you can access its children using properties like children, child nodes, first child, last child, and so on. Here's a quick example: var parent element $document.getElementById parent, var first child element $parent element, a first child, var second child element $parent element children. This code fetches the first and second child elements of the parent element. To sum up, some methods return collections of elements, while others return a single element or null if no matching element is found. Always ensure that the DOM has loaded before trying to access elements using JavaScript. You can do this by placing your script at the bottom of the HTML document or by using event listeners like DOM content loaded. And that's a wrap on accessing elements in JavaScript. Remember, practice makes perfect. So try these methods out, experiment with them, and see how they can make your JavaScript journey smoother and more efficient.
Have you ever wondered how to modify HTML elements using JavaScript? Well, you're not alone. It's a common question that sparks curiosity in the minds of many. Let's dive into some common techniques to manipulate HTML elements with JavaScript. Firstly, to change the HTML content inside an element, use the inner HTML property. Imagine you have an element with an ID of myElementId. You can update the content with the following code: var element =document, get element byid, myElementId, element inner HTML =new content. Scene script. But what if you only want to change the text content of an element, ignoring any HTML tags? That's where the text content property comes into play. The code for this will look something like var element =document, get element byid, myElementId, element.textContent =new text content. Attributes of an element can also be modified. This can be done using setAttribute or by directly accessing the property related to that attribute. Here's how it works. Var element =document at get element byid myElementId, element set attribute src new-image.jpg / changing src attribute element rf =new link / directly changing href property output. Now, what if you want to modify the CSS styles of an element? The style property is your friend. Here's how to do it. Var element =document get element byid myElementId, element.style.color =red, element.style.background color =yellow. Adding or removing CSS classes from an element is another common task. This can be accomplished using the class list property. Here's how to add a new class and remove an old one. Var element =document at get element byid myElementId, element class list add new class, element class list remove old class. Finally, creating new HTML elements dynamically and appending them to the document is also possible. Here's how to create a new div and add it to the body of the document. Var new element =document.create element div, new element text content =new element document.body append child new element. These are just a few examples of how you can modify HTML elements in JavaScript. Depending on your specific needs, you may need to use other methods or combine these techniques to achieve your desired outcome. In summary, JavaScript provides a wide range of methods to modify HTML elements. From changing the inner HTML and text content, to altering attributes and styles, to adding or removing classes, and even creating new elements. It's all about knowing which method to use when and how to use it effectively. So go ahead and explore these methods. Practice them, experiment with them, and you'll soon find yourself able to manipulate HTML elements with ease using JavaScript.
Ever wondered how to create HTML elements dynamically in JavaScript? Well, it's a powerful feature that can be used to build and manipulate the structure of a web page programmatically. Let's dive into the process. First things first, you need to create an element. This is achieved using the document.createElement method. This method allows you to specify the tag name of the element you want to create. For instance, if you want to create a new div, you would write something like this: var new div =document create element div. Now that the element is created, it's time to set its properties. You can set attributes, styles, and other properties of the newly created element. For example, you can assign an ID to your new div and set its text content like so: new div.id =new divid. New div text content this is a new div. Great! Now you have a new div with an ID and some text content, but it's still not visible on your web page. Why? Because you need to append it to an existing element in the document. Let's say you have a container in your HTML where you want to add this new div. You would do something like this: var container =document, get element byid, container, container, append child new div. And voila! Your new div is now part of the DOM and visible on your web page. Let's put all these steps together into a single code snippet. / create a new div element. var new div =document.create element div. / set properties of the new div div.id =new divid. New div.text content this is a new div. New div.style background color light blue. / append the new div to an existing element in the document. var container =document, get element byid, container, container, append child new div. This code creates a new div element. sets its ID, text content, and background color, and then appends it to an existing element with the ID container in the document. And that's it. You've just learned how to create HTML elements dynamically in JavaScript. The same process can be used to create other types of elements like span, p, img, and so on. Customize them as needed and append them to the document or other elements in the DOM. This gives you a great deal of flexibility and control over your web page structure and content. Remember, JavaScript's power lies in its ability to manipulate the DOM dynamically and interactively. Keep experimenting, keep coding, and you'll uncover even more ways to make your web pages dynamic and interactive.
Ever wondered how to add JavaScript to an HTML page? Well, it's not as complicated as it may seem. In fact, there are a few simple ways to do it. First up, inline JavaScript. This method involves including JavaScript code directly within the HTML document. You use the script element for this. You can place this script tag in the head or body section of your HTML document and write your JavaScript code inside it. For instance, a basic HTML page with a script tag in the head section printing "Hello World" to the console would look like this. Open the HTML document with the doctype declaration, followed by opening the HTML and head tags. Then, add the meta charset and meta viewport tags for proper formatting. Next, define the title of your page within the title tags. After that, open the script tag and write your JavaScript code inside it. For example, you could write a simple console log statement to print "Hello World." Finally, close the script, head, and HTML tags. Now, that's one way to do it. But what if you want to keep your HTML and JavaScript code separate? This brings us to the second method, using an external JavaScript file. In this method, you include JavaScript code from an external JS file by specifying the source file in the src attribute of the script tag. This is a great way to improve maintainability and organization by separating HTML and JavaScript code into different files. The HTML document structure would look quite similar to the previous example, but instead of writing JavaScript code within the script tag, you would specify the external JavaScript file in the src attribute. Let's say your JavaScript code is in a file named script.js. The script tag would then look like this. The JavaScript code in script.js would be something like a console log statement printing "Hello World." Finally, there's the option of using event handlers. This method involves attaching JavaScript code to specific HTML elements using event attributes like onClick, onMouseOver, and so on. This is commonly used for handling user interactions with elements. For instance, you could have a button in your HTML document that displays an alert saying "button clicked" when clicked. The button element would look like this: "Click me." Now, which method should you choose? Well, it depends on your needs and coding style. However, using external JavaScript files is generally preferred for larger projects, as it keeps the code organized and maintainable. In summary, you have three main ways to add JavaScript to an HTML page: inline JavaScript, external JavaScript file, and event handlers. Each has its own benefits, so choose the one that best fits your needs. Happy coding! Ever pondered how to make web applications interactive? The answer lies in event handling in JavaScript. It's an essential concept that enables us to respond to user interactions like clicks, key presses, and mouse movements, executing specific code in response to these events. To kick things off, we'll discuss adding event listeners. The addEventListener method allows us to attach an event handler function to an element. It takes two arguments, the event type and the event handler function. Here's a simple example. Imagine a button on a web page, which we'll call MyButton. In JavaScript, we can get a reference to this button using document.getElementById, MyButton. Now we can add an event listener to this button that logs "button clicked" to the console every time the button is clicked. Next, we have event handler functions. These are the functions that get called when the specified event occurs. You can define these functions in line right inside the addEventListener method. or separately. Here's an example where we define the function separately. First, we define a function called handleClick that logs button clicked to the console. Then, we add this function as an event handler for the click event on our button. But what if we want to stop listening to an event? That's where removing event listeners comes in. We can use the remove event listener method to achieve this. It requires the same arguments as add event listener, the event type, and the event handler function. For instance, in the handleClick function, we can remove the event listener for the click event on our button. Lastly, we have the event object. When an event occurs, an event object is automatically passed to the event handler function. This object contains information about the event, such as the type of event, the target element, and any additional data relevant to the event. For example, we can log the target element to the console every time our button is clicked. To summarize, event handling in JavaScript involves adding event listeners to elements, defining event handler functions that execute when these events occur, removing event listeners when they're no longer needed, and using the event object to get more information about the events. By mastering these concepts, you can create dynamic and interactive web applications that respond to a wide range of user interactions.
Have you ever wondered how to handle errors in JavaScript effectively? Well, you're in for a treat. Today, we're exploring the various mechanisms JavaScript provides for handling errors and exceptions, ensuring your code is robust and reliable. First on the agenda is the try.catch statement. This statement is your best friend when it comes to catching and handling exceptions that occur within a block of code. Imagine there's a section of your code that might throw an exception. You can wrap it in a try block. If an error does occur, the catch block swoops in, handling the exception and preventing your program from crashing. Next up is the throw statement. This is a handy tool for signaling errors or exceptional conditions in your code. You can throw your own exceptions, letting your program know when something's gone awry. It's like the flare gun of your JavaScript code, alerting you to potential problems. Then we have the error object. JavaScript provides built-in error objects like error, syntax error, reference error, and type error, among others. These can be thrown or caught, giving you a variety of ways to signal and handle different types of errors. It's like having a toolbox full of different error handling tools, each with its own specific purpose. Now let's move on to the finally block. This block is the reliable workhorse of your error handling code, executing code regardless of whether an exception is thrown or not. You can use this block to ensure certain code always runs, even in the face of errors. It's like the cleanup crew coming in after the show to make sure everything's tidy and in order. Last but not least, we have global error handling. You can set up a global error handler using the window.onError event handler or the window.addEventListener error handler method. This is your last line of defense, catching any unhandled errors that might have slipped through the cracks. It's like the goalie of your JavaScript code, ready to block any unexpected errors that come its way. In summary, JavaScript provides a variety of techniques for handling errors, from the try-catch statement and throw statement to the error object, finally block, and global error handling. By using these techniques effectively, you can make your JavaScript code more resilient and easier to debug, ensuring your program runs smoothly and efficiently.
Why is error handling such a vital part of JavaScript? Well, ponder this. What happens when an unhandled error occurs? It can result in unpredictable behavior or worse, cause the application to crash. But fear not, JavaScript provides a way to catch these unhandled exceptions, and it's called global error handling. Now, how does one go about setting up global error handling in JavaScript? There are two prominent methods, and the first one involves using window.onError. The window.onError event handler is an omnipresent guard that springs into action whenever an uncaught JavaScript error occurs. It's like a safety net for unhandled errors at the global level. Here's an example of how you can set it up. In your JavaScript code, simply assign a function to window.onError. This function should take 5 parameters: message, source, lineno, colno, and error. You might then log the error or perform other actions. For instance, you might write something like this: window.onError =sign function, message, source, lineno, colno, error, These parameters provide valuable information about the error, such as the error message, the source file where the error occurred, the line number, column number, and the error object itself. But that's not the only way. You can also latch on an event listener for the error event to the window object using the addEventListener method. This approach offers a more flexible, modern way to handle errors. Here's how it can be done. Window.addEventListener, error, function event. The error event object comes with properties such as message, file name, lineno, colno, and error, which provide information about the error. So there you have it. Setting up global error handling in JavaScript. By implementing this, you can catch and handle any unhandled errors in your JavaScript code. This not only improves the robustness of your application, but makes it more reliable. So go on, give your application that extra layer of protection it deserves. Ever wrestled with the complexities of string manipulation in JavaScript? Ever wished for a simple, elegant solution to handle variables, expressions, and multi-line strings? Today we delve into the world of template literals, a gem in the feature set of ES6, which provides an easy and effective way to work with strings. A template. Literal is enclosed in backticks, not the usual single or double quotes we're used to. This minor change, however, opens up a world of possibilities. Let's explore these with an example. Imagine we have a constant named name with the value Alice and another constant age with the value 30. Now we want to create a greeting using these variables. With template literals, we can easily interpolate these variables using the $ syntax in our string. Thus our greeting becomes, when we log this greeting, we get, "Hello, my name is Alice and I'm 30 years old." But wait, there's more. Template literals aren't just about interpolating variables. They are also about making your code more readable, especially when dealing with multi-line strings. For example, we can create a multi-line string as easily as this. This is a multi-line string. It's incredibly convenient for formatting text over multiple lines. When we log this string, it maintains its structure, line breaks and all. Now hold on to your hats because we're about to take this up a notch. Template literals can contain any valid JavaScript expression within the $. This means we can perform operations, call functions, and yes, even nest template literals. For instance, if we have two constants a and b with values 5 and 10 respectively, we can calculate their sum within a template literal like so. Logging this gives us the sum of 5 and 10 is 15. In conclusion, template literals make working with strings in JavaScript a breeze. They offer a concise, readable way to handle dynamic content, multi-line strings, and complex expressions. They are a powerful tool in the JavaScript arsenal, making string manipulation simpler, cleaner, and infinitely more manageable. So the next time you're faced with a complex string task, remember the power of template literals and let them do the heavy lifting for you.
Ever wondered how to make your JavaScript code more concise and readable? Destructuring assignment is a powerful feature introduced in ECMAScript 2015, also known as ES6, that allows you to extract values from arrays or properties from objects and assign them to variables. This makes your code more streamlined and, quite frankly, easier to understand. Let's dive into the different destructuring types, starting with array destructuring. Think of an array with 3 elements, 1, 2, and 3. To extract these values, you would use square brackets, like so, const equals sign array. Now if you log A, B, and C, you'll get 1, 2, and 3 respectively. You can even skip elements by using commas, like const equals sign array. This will give you the first and third element, skipping the second. Now, let's move on to object destructuring. Instead of square brackets, we use curly braces for object destructuring. For an object with properties x, y, and z, you would write const x, y, z equals sign obj. This will extract the values of x, y, and z from the object. You can also assign default values in case a property isn't present in the object. For instance, const a equals sign 10, b equals sign 20, c equals sign 30 will give you 10 for a, as it's not present in the object, 2 for b, and 3 for c. Nested destructuring is another handy tool. It allows you to destructure nested arrays and objects. For a nested array like 1, 4, you can extract the second and third element from the nested array with const equals sign nested array. Similarly, For a nested object like outer, inner 42, you can get the inner value using const, outer, inner, =, nested obj. Finally, the rest syntax, represented by 3 dots, captures the remaining elements of an array or remaining properties of an object. For an array-like, you can extract the first element and the rest with const =, numbers. This will give you one for first and for rest. Similarly, for an object like x, 1, y, 2, z, 3, you can extract x and the rest with const x, rest props. In summary, destructuring assignment is a nifty way to work with arrays and objects in JavaScript. It makes your code more concise, more readable, and easier to manage. So, the next time you find yourself dealing with complex data structures, remember destructuring assignment. It might just be the tool you need to simplify your code.
Ever wondered how JavaScript allows you to specify default values for function parameters? Well, it's all thanks to default parameters. This feature, introduced in ECMAScript 2015 or ES6 for short, provides a convenient way to handle values that are missing in function calls. To illustrate, consider this JavaScript function. In this example, the greet function has a default parameter, name, which is set to world. When the function is called without providing an argument for name, the default value world is used. So if you call, the output will be hello world. However, if an argument is provided, such as John, the provided value is used instead of the default. So outputs hello John output, but that's not all. Default parameters in JavaScript can also be expressions. Here's an example. In this function, the default value of the height parameter is set to width times 2. This allows you to calculate the area of a rectangle with a default aspect ratio of 2:1. So if you call, the output will be 16 since height is calculated as 4 times 2, which equals 8. If you call, the output will be 24, as height is explicitly provided as 6. Output. These examples demonstrate how default parameters can significantly enhance the flexibility and usability of functions in JavaScript. They are particularly useful for defining functions with optional arguments or for providing fallback values when certain arguments are not provided. So next time, when you're working with JavaScript functions, don't forget to leverage the power of default parameters to make your functions more robust and adaptable. To sum up, default parameters in JavaScript allow you to specify default values for function parameters, handle missing values in function calls, and even use expressions as default values. They were introduced in ECMAScript 2015 and have since become a powerful tool in the JavaScript developer's toolkit.
Ever wondered how classes work in JavaScript? Well, classes, introduced in ECMAScript 2015, are a more convenient and familiar way to create constructor functions and define object blueprints. First off, declaring a class is straightforward. You use the class keyword followed by the class name. For example, imagine a basic class called person with properties like name and age and a method to greet others. Within a class, there's a special method called the constructor. This method is crucial for initializing newly created objects. It's automatically invoked when an object is created from the class. But classes aren't just about constructors. You can define other methods within a class too, just like you would in an object literal. These methods can perform various actions or operations on class instances. Creating instances of a class is also simple. You use the new keyword followed by the class name, and you can pass arguments to the constructor method. So, if you create 2 instances of the person class, Alice and Bob, they can each greet you using their own greet method. Inheritance is another powerful feature of classes. Through the extends keyword, a subclass can inherit properties and methods from a superclass. For instance, consider a student class that extends the person class. The student class inherits the properties and methods of the person class, and can also have its own properties and methods. Last but not least, classes support static methods. Defined with the static keyword, these methods are called on the class itself, not on instances of the class. They're handy for utility functions that aren't tied to specific instances. Here's an example with a mathutils class that includes a static method to add numbers. In summary, classes in JavaScript provide a cleaner, more structured way to work with constructor functions and prototypes. They make JavaScript more approachable for developers familiar with object-oriented programming paradigms. So the next time you're working on a JavaScript project, consider using classes to make your code more organized and easier to manage.
Ever pondered over what static methods in JavaScript are and how they function? Well, it's time to demystify this concept. Picture static methods as the mavericks of JavaScript. They're individualistic, not tied to any class instance, yet they're part of the class. In the realm of JavaScript, a static method is a method attached directly to the class rather than to instances of the class. It's like a library book that's always on the shelf, ready to be used by anyone without needing to be checked out. Imagine a class in JavaScript named MathUtils. Within this class there are two static methods, add and subtract. These methods are defined using the static keyword like this: static add xy, return x plus y. Static subtract xy, return xy. These methods are accessible directly from the class, meaning they can be called on the class itself without creating an instance of MathUtils. So, if someone wants to add 5 and 3, they would simply call MathUtils add 5, 3, which would return 8. Similarly, if they want to subtract 4 from 10, they would call MathUtils subtract 10, 4, and get 6 as the output. But here's the interesting part. Static methods can't access instance properties or methods. That's because they're not called on instances of the class, but on the class itself. They operate solely on the arguments passed to them. So why use static methods, one might ask? Well, they're incredibly useful for utility functions that aren't tied to specific instances of the class. Think of them as your go-to toolbox for tasks that don't require instance-specific data. They're perfect for helper functions, factory methods, or other operations. To summarize, static methods in JavaScript are methods belonging to the class itself rather than its instances. Defined using the static keyword, they're accessed directly from the class without needing an instance. They operate on the arguments passed to them and can't access instance properties or methods. Static methods are often used for utility functions, factory methods, or other operations that don't require instance-specific data. So the next time you're coding in JavaScript, remember the maverick static methods. They're always there, ready to lend a hand, no instances attached.
Ever wondered how to handle an indefinite number of arguments in a function, or how to merge arrays and objects in JavaScript? The answer lies in two powerful features introduced in ECMAScript 6, also known as ES6, the rest and spread operators. First up, the rest operator. This handy tool allows you to represent an indefinite number of arguments as an array within a function parameter. It's symbolized by 3 consecutive dots. Picture this scenario. You have a function that sums up numbers. Instead of specifying each number individually, you can use the rest operator to gather all arguments into one array. So a function like this, function sum console.log sum 1, 2, 3, 4, 5, will give you an output of 15. It's that simple. The rest operator gathers all the arguments passed to the sum function into an array named numbers. Now onto the spread operator. This operator, represented by the same 3 consecutive dots, allows you to expand an array or object into individual elements. For arrays, it works like this: const r1 equals, const r2 equals, const merged array equals, console.log merged array. This will output. The spread operator spreads the elements of r1 and r2 into a new array. The same principle applies to objects. For example, const obj1 a1 b2, const ob2 equals cd4, const merged object equal to obj1 to obj2 console log merged object. This will output a1 b2 c3 4. The spread operator spreads the properties of obj1 and obj2 into a new object. So, in summary, the rest operator is used in function declarations to capture an indefinite number of arguments into an array parameter. On the other hand, the spread operator is used to expand arrays or objects into individual elements or properties. Both operators allow for concise and expressive code and have a wide range of uses in JavaScript, from function parameter handling to array manipulation and object merging. With these two operators in your toolkit, you'll be well equipped to handle the dynamic and flexible nature of JavaScript.
Ever pondered the significance of JavaScript modules in code organization and maintainability? Well, it's time to delve into the intriguing world of JavaScript modules, a world that boasts of reusable pieces of code that encapsulate functionality. These modules can be exported from one file and imported into another, creating a seamless flow of information and functionality. JavaScript modules are the unsung heroes behind code organization. They are the vigilant guards that reduce namespace pollution, ensuring that your code remains clean, readable, and efficient. But how do they do this? The answer lies in the two main types of JavaScript modules, ES6 and CommonJS. ES6 modules or ECMAScript 6 modules are part of the standardized module system introduced by ES6. They treat each file as a separate module. This is where the magic words export and import come into play. These keywords define what should be exported from a module and what should be imported into another module. For instance, consider a module named math.js that exports two functions, sum and subtract. Another module can import these functions and use them as needed. Just like that, we have a neat, organized code that is easy to understand and maintain. On the other hand, we have CommonJS modules, the module format used in Node.js. This format uses module exports to export values from a module and require to import values into another module. Using the same math.js example, we can export the sum and subtract functions using module exports and import them into another module using require. While ES6 modules are widely used in modern web development and browser-based applications, CommonJS modules still hold their ground in Node.js environments. Each has its strengths and applications, contributing to the diverse and dynamic landscape of JavaScript. In summary, JavaScript modules are instrumental in code organization and maintainability. They break down code into smaller, manageable units, fostering code reuse and collaboration. They also facilitate better dependency management and reduce the risk of naming conflicts. So the next time you find yourself navigating through a JavaScript codebase, take a moment to appreciate the elegance and efficiency of JavaScript modules. They are, after all, the unsung heroes of code organization and maintainability.
Good day, everyone. Ever wondered about that unique and immutable data type in JavaScript called symbols? If you're scratching your head, don't worry. By the end of this video, you'll have a clear understanding of what symbols are and how they function in JavaScript. Symbols, a new primitive data type, made its debut in ECMAScript 6, popularly known as ES6. Now, what makes symbols stand out? Well, each symbol value is unique. Yes, even if two symbols carry the same description, they are still distinct. This uniqueness of symbols is what makes them a perfect fit for identifying object properties. But that's not all. Symbols are also immutable, meaning they cannot be changed or modified once created. This immutability, coupled with their uniqueness, makes symbols a safe and secure way of identifying properties in an object. So how do we use symbols as object keys? It's quite straightforward. You create a symbol, and then you use it as a key for your object property. This process ensures that your object property has a unique identifier, which completely eliminates the risk of naming collisions within your object properties. But what about sharing symbols across different parts of your application? That's where the symbol registry comes into play. You can register symbols in the symbol registry, which allows you to share them across your entire application. Symbols can also carry an optional description. This description is a string that helps you identify the symbol. However, it's important to note that this description doesn't affect the uniqueness of the symbol. It's mainly for debugging purposes. Here's a quick recap of what we've covered about symbols in JavaScript. Symbols are unique, immutable values that can be used as identifiers for object properties. They can be registered in the symbol registry for sharing across your application, and they can carry an optional description for identification. Symbols, with their uniqueness and immutability, offer a robust way of managing and identifying object properties in JavaScript. So that's all about symbols in JavaScript, a unique and immutable data type that can significantly enhance your coding efficiency and security. Remember, the symbol data type is your friend, and knowing how to use it effectively can be a game changer in your JavaScript programming journey. Happy coding!
Ever wondered how inheritance works in JavaScript? Well, buckle up because we're about to embark on an enlightening journey through the fascinating world of JavaScript inheritance. Inheritance, at its core, is a mechanism that allows objects to inherit properties and methods from other objects. Think of it as a family lineage where traits are passed down from parents, to their offspring. In JavaScript, this parent-offspring relationship is often referred to as the superclass-subclass relationship. Now, the first thing to understand here is the concept of the prototype chain. Each object in JavaScript possesses an internal property known as. This property serves as a reference to another object, its prototype. When you try to access a property or method on an object, JavaScript first checks if it's present directly on that object. If it's not, it journeys up the prototype chain, hunting for that property or method until it finds it or reaches the end of the chain. At the pinnacle of this prototype chain is the object prototype object. This object is like the common ancestor in our family lineage analogy. It contains properties and methods that are shared by all JavaScript objects. Functions like toString and ValueOf that you might have used before are all part of this object prototype. Now, you might wonder, how do we create these objects with a shared prototype? That's where constructor functions come into play. When invoked with the new keyword, a constructor function crafts a new object instance, with its property pointing back to the prototype of the constructor function. This leads us to the heart of JavaScript inheritance, prototypal inheritance. Objects inherit properties and methods from their prototypes. By adding properties and methods to a constructor function's prototype object, every instance created by that constructor function gets those properties and methods. Let's illustrate this with a simple example. Consider two constructor functions, animal and dog. Animal is our parent constructor function, and dog is our child constructor function. We add a method sayName to the animal's prototype. Then we make dog inherit from animal's prototype using Object.create. We also add a method bark to the dog's prototype. Now, when we create an instance of dog, it can access both sayName from animal and bark from dog. This, my friends, is the magic of prototypal inheritance. To sum it up, inheritance in JavaScript is about objects inheriting properties and methods from other objects through a prototype chain. This is achieved using constructor functions and the property. And that's how the wonderful world of JavaScript inheritance works. Enjoy coding.
Have you ever wondered how inheritance works in JavaScript using ES6 class syntax? Perhaps you've been learning JavaScript and found yourself puzzled by the concept. Well, sit back, relax, and allow us to clarify this for you. Inheritance in JavaScript using ES6 class syntax is a fantastic concept that allows us to create hierarchical relationships between classes. It's all about parent and child classes, with the child inheriting properties and methods from the parent. Let's begin with class declarations. In ES6, we use the class keyword to declare a new class. This declaration involves naming the class and defining its body, which includes methods and properties. For example, consider a class named Animal. This class might have properties like name and methods like speak. Next up is the constructor method, a unique method called whenever a new instance of the class is created. The constructor method is where we initialize our object properties. Now we get to the heart of inheritance, class inheritance. By using the extends keyword, we can create a subclass, also known as a child class, which inherits from another class, known as the parent class. This means the subclass inherits all properties and methods from the parent class. Let's consider a subclass named dog that extends our animal class. This subclass not only inherits the properties and methods from animal, but can also have its own unique properties and methods. Within the constructor of our subclass, we use the super keyword. This keyword is used to call the constructor of the parent class, which is crucial for initializing properties defined in the parent class. The beauty of subclasses is their ability to override methods defined in the parent class. This is known as method overriding. It means that if a method is called on an instance of the subclass, JavaScript will first check if the method exists in the subclass. If it doesn't find it there, it looks for the method in the parent class. So as a recap, inheritance in JavaScript using ES6 class syntax involves class declarations, constructor methods, class inheritance, the super keyword, and method overriding. It's a powerful way to create hierarchical relationships between classes, allowing for code reusability and organization. Remember, the child class inherits all properties and methods from its parent, but it can also have its own unique properties and methods and can override methods from the parent class. With these concepts in your toolkit, you're well on your way to mastering JavaScript inheritance. Happy coding!
Ever wondered what the map method in JavaScript is or why it's so important? Well, today is your lucky day because we're going to dive deep into its workings, syntax, and practical examples. Starting with the basics, the map method is a powerful JavaScript tool that creates a new array by calling a function on every element in the original array. It returns a new array of results with the function applied to each element. Here's the syntax. The map method is called on an array, and it takes a function as its argument. This function can have up to 3 parameters: the current value, which is the current element being processed in the array, the index, which is the index of the current element being processed, and the array itself, which is the array the map method was called upon. Now, let's see how this works in practice with some examples. Imagine an array of numbers and we want to double each number. We can achieve this using the map method. The end result would be a new array with each number doubled. Or perhaps we have an array of fruit names written in lowercase and we want them all to be in uppercase. Again, using the map method, we can create a new array with all fruit names in uppercase. The map method isn't only limited to arrays of numbers or strings, it can also be used with arrays of objects. Suppose we have an array of person objects, each with a name and age property, and we want to create a new array with just the names. The map method can help us achieve this. Finally, we can use the map method to calculate the square root of numbers in an array. So, what's the takeaway from all of this? The map method in JavaScript is a powerful tool for transforming elements in an array. It offers a concise syntax for carrying out transformations without the need for explicit iteration. It's immutable, meaning it doesn't change the original array, but instead creates a new one. It promotes a functional programming style, leading to cleaner and more declarative code. However, it's not without its drawbacks. While convenient, the map method can introduce a performance overhead, especially for large arrays or complex transformations. It may not always be the most appropriate choice, especially if the transformation logic is complex or involves side effects. Lastly, the callback function passed to map must be a function expression, which can sometimes lead to less readable code. That's it for the map method in JavaScript. It's a versatile tool to have in your coding arsenal, helping you to manipulate arrays with ease. So next time you're faced with an array that needs transforming, why not give the map method a try?
Have you ever wondered how to filter out elements from an array in JavaScript? Well, the filter method is a powerful tool that can help you do just that. The filter method in JavaScript creates a new array with all elements that pass the test implemented by the provided function. It does not change the original array. The syntax for the filter method looks like this. The filter function is called on an array and takes in a function as an argument. This argument function should return either true or false. The function is applied to each element in the array in turn. If the function returns true for a particular element, that element gets included in the new array. If it returns false, the element is left out. The function you pass into the filter method gets 3 parameters: the current element being processed, the index of the current element, and the array filter was called upon. Output. Let's consider an example. Suppose you have an array of numbers and you want to filter out only the even numbers. Here's how you can do it using the filter method. The filter method iterates over each number in the array, checks if the number is even, and if so, includes it in the new array. The result is a new array with just the even numbers. Output. Scene script. But what if you want to filter strings? Say you have an array of names and you want to select only those that start with A. The filter method can handle that too. The filter method can even work with arrays of objects. Suppose you have an array of person objects and you want to filter out only those who are over 30. Here's how. Output. The filter method is a powerful tool for selecting specific elements from an array based on custom criteria. It provides a concise syntax for selecting elements based on a given condition without the need for explicit iteration. It does not mutate the original array. Instead, it creates a new array with the filtered elements, leaving the original array unchanged. The filter method promotes a functional programming style by allowing you to apply a predicate function to each element of an array, which can lead to cleaner and more declarative code. And often, using filter results in more readable code compared to traditional loop constructs, especially for simple filtering conditions. However, while filter provides a convenient way to select elements from an array, it may introduce a performance overhead compared to traditional loops, especially for large arrays or complex filtering conditions. And in some cases, using filter may not be the most appropriate choice, especially if the filtering logic is complex or if side effects are involved. So there you have it. The filter method in JavaScript is a powerful tool for filtering elements from an array based on any criteria you provide. It's easy to use, flexible, and can greatly simplify your code. Remember, the key is to provide a function that returns true for elements you want to include, and false for those you want to exclude. Happy coding!
Ever pondered over how to sum up values or find the maximum value in an array using JavaScript? Well, today we're diving into the world of JavaScript's reduce method, a powerful tool that can simplify these operations. The reduce method is all about executing a reducer function on each element of an array, culminating in a single output value. From summing up numbers to concatenating strings, this method is a game changer. But how does it work? The syntax of reduceum is as follows: array reduce callback, accumulator current value index. Here we have several parameters at play. The callback is a function that gets called for each element in the array. This function takes 4 arguments: accumulator, current value, index, and array. The accumulator, as the name suggests, accumulates the return values of the callback. It's essentially the result from previous iterations. The current value is the current element being processed in the array. The index, which is optional, is the position of the current element in the array, while array is the array on which reduce was called upon. An optional initial value can also be used as the first argument to the first call of the callback. If no initial value is provided, the first element in the array is used as the initial accumulator value and skipped as the current value. Now let's see the reduce method in action. Assume we have an array of numbers, 1, 2, 3, 4, 5. We want to sum up these values. Here's how we can do it. Const numbers equals sign, const sum equals sign numbers, reduce, accumulator current value equals sign, accumulator plus current value 0. Console, log sum. In this example, the output will be 15, the sum of all numbers in the array. Now what if we want to find the maximum value in an array? Here's how we can achieve this. Const values equals sign, const max equals sign values, reduce, accumulator current value equals sign, mathmax accumulator current value values, console log max. In this scenario, the output will be 30, the maximum value in the array. By now, you should have a good grasp of the reduce method in JavaScript. It's a powerful tool that allows you to perform operations on each element in an array and reduce it to a single output value. Remember, the accumulator stores the return value of the callback function, which is remembered across each iteration throughout the array, resulting in a final accumulated value. So the next time you find yourself needing to sum up values, find the maximum value, or perform similar operations, think reduce. It just might be the solution you're looking for.
Ever grappled with the task of reducing an array from right to left in JavaScript? If so, today, we delve into the ReduceRight method. This function can be a game changer, especially when you need to traverse an array from the last element all the way to the first one. The ReduceRight method applies a function against an accumulator and each value of the array from right to left, reducing it to a single value. The method executes the provided function once for each element present in the array. It passes 4 arguments: the initial value or value from the previous iteration, the current element value, the current element index, and the array over which iteration is occurring. To illustrate this, consider the following syntax: array, ReduceRight, callback, accumulator, current value, index, array, initial value. Here, the callback is a function to execute on each element in the array. The accumulator accumulates the callback's return values. It holds the accumulated value previously returned in the last invocation of the callback, or the initial value if supplied. The current value refers to the current element being processed in the array. The index and array parameters are optional and represent the index of the current element being processed and the array ReduceRight was called upon respectively. The initial value, which is also optional, is a value to use as the first argument to the first call of the callback. To bring this concept to life, let's consider an example. Suppose we have an array of 5 elements, 1, 2, 3, 4, and 5. We want to find the sum of these elements. Using the ReduceRight by C method, we define the callback function as the sum of the accumulator and the current value. When we log the sum, the output is 15, which is the sum of 5, 4, 3, 2, and 1. This method has its advantages. It's particularly useful for operations that require traversal from right to left in an array. It also offers flexibility in customizing the reduction process through the callback function. However, it's not without its downsides. The ReduceRight method may not be as intuitive as other array methods like map, filter, or ForEach. It requires an understanding of the accumulator and callback function's behavior, which can be complex in certain cases. Additionally, it may not be the most efficient solution for all use cases, especially for simple array transformations. In summary, the ReduceRight method in JavaScript is a powerful tool for reducing an array from right to left. It provides you with the flexibility to customize your reduction process, but requires a clear understanding of how accumulator and callback functions work. While it's not always the most efficient solution, when used correctly, it can significantly streamline your code. Remember, the key to mastering JavaScript is understanding the tools at your disposal, and ReduceRight is certainly one of them.
Ever wondered how to check if all or at least one element in a JavaScript array meets a certain condition? That's where the every and some functions come into play. These two array methods in JavaScript are incredibly handy for testing whether all or some elements in an array satisfy a specified condition. Dive right into the every function. The every function tests whether all elements in an array pass a test provided by a function. It's like a stern examiner inspecting every single element and ensuring they all meet the criteria. If they do, it proudly returns true. But if even one element fails the test, it immediately returns false. The syntax for every involves calling it on an array and passing a callback function. This callback function takes up to 3 arguments, the current element being processed, the index of that element, and the array itself. Optionally, you can specify a thisArg to use as this when executing the callback. For instance, imagine an array of numbers from 1 to 5. Using every, you can check if all these numbers are greater than 0. The function will return true, as indeed all numbers in the array are positive. But if you check if all numbers are even, it's going to return false, because not all numbers in the array are even. Now, shift gears and look at the sum function. The sum function is a little more lenient. It tests whether at least one element in the array passes the test provided by a function. If at least one element passes the test, it celebrates by returning true. If not, it sadly returns false. The syntax for sum is similar to every. It takes a callback function with the same arguments, the current element, its index, and the array. Again, you can specify a thisArg. Using the same array of numbers, you can use sum to check if at least one number is negative. The function will return false because none of the numbers in the array are negative. But if you check if at least one number is even, it's going to return true because there are indeed even numbers in the array. In both these examples, the every and some functions return Boolean values based on the conditions specified in the callback functions. To sum it up, every and some are powerful JavaScript array methods that allow you to test all or some elements in an array against a condition. The every function is strict, requiring all elements to pass the test, while the sum function is more forgiving, needing only one element to pass. Remember, these methods return a Boolean value, giving you a clear, true or false answer to your condition. Keep these tools in your JavaScript toolbox. You never know when they might come in handy.
how to locate a specific element's position in a JavaScript array? Well, that's where the JavaScript methods IndexOf and LastIndexOf come into play. The IndexOf function in JavaScript serves to find the first index at which a specified element appears in an array. If the element is not present, it returns -1. The syntax for this function is as follows: array index of a search element from index. Here, the search element is the element you're looking for in the array. The from index, which is optional, is the index from which the search begins. If you leave it out, the search starts from the very beginning of the array, that is, index 0. So, the IndexOf function starts scanning the array, and as soon as it finds the first occurrence of the element you're searching for, it returns the index. If the element is not found, it returns -1. The benefit of this function is that it swiftly finds the index of the first occurrence of an element in an array. However, the downside is that it only returns the index of the first occurrence, not all occurrences. Now, let's switch gears to the LastIndexOf function. This function is similar to IndexOf, but with a twist. It returns the last index at which a specified element can be found in the array or -1 if it's not present. The syntax is almost identical to IndexOf. Array LastIndexOf search element from index. The key difference is that when the from index is omitted, the search starts from the end of the array, not the beginning. So the LastIndexOf function begins scanning the array from the end and returns the index of the last occurrence of the element you're searching for. If the element is not found, it returns -1. It's especially useful when you need to find the index of the last occurrence of an element in an array. However, like IndexOf, it only returns the index of the last occurrence, not all occurrences. To illustrate this, consider an array of numbers. If you use IndexOf 3, it returns 2, which is the index of the first occurrence of 3. However, if you use LastIndexOf 3, it returns 5, which is the index of the last occurrence of 3. In conclusion, both IndexOf and LastIndexOf are powerful tools in JavaScript for finding the position of elements in an array. While they have similar syntax and functionality, IndexOf is useful for finding the first occurrence of an element, and LastIndexOf is useful for finding the last occurrence. Each has its advantages and disadvantages, but understanding how and when to use these methods will greatly enhance your ability to manipulate and interact with arrays in JavaScript.
Ever wondered about the difference between the find and FindIndex functions in JavaScript? Let's dive into it. Imagine you're dealing with an array and you need to locate a specific element. JavaScript offers a myriad of methods, but today we're focusing on two: find and FindIndex. The find function in JavaScript returns the value of the first element in the array that satisfies a provided testing function. If no elements meet this criterion, it returns undefined. The syntax looks something like this: array find callback, element index array, this arg. The callback function tests each element of the array and takes 3 arguments: element, index, and array. The thisArg is an optional object to which the this keyword can refer in the callback function. This function executes the callback function for each array element until it finds one where the callback returns a truthy value. If such an element is found, find immediately returns the value of that element. Otherwise, it returns undefined. The advantage of find is that it returns the value of the first element that satisfies the condition, which can be useful for searching arrays. However, it stops iteration once the first matching element is found, which means it may not find all matching elements. Moving on to the FindIndex function. This function returns the index of the first element in the array that satisfies a provided testing function. If no elements meet this criterion, it returns -1. The syntax is very similar to the finder function: array, find index, callback element, index array, this arg. The callback function tests each element of the array and takes 3 arguments: element, index, and array. The thisArg is an optional object to which the this keyword can refer in the callback function. Just like the find function, FindIndex executes the callback function for each array element until it finds one where the callback returns a truthy value. If such an element is found, FindIndex immediately returns the index of that element. Otherwise, it returns -1. The main difference from find is that FindIndex returns the index of the first matching element, not the value. This can be useful for locating elements in an array. However, just like find, it stops iteration once the first matching element is found, which means it may not find all matching elements. For example, if you have an array of numbers and you're looking for the first number greater than 2, find would return the number itself, while FindIndex would return the index of that number in the array. In conclusion, both find and FindIndex are powerful tools for working with arrays in JavaScript. While they have similar syntax and offer similar functionality, the key difference lies in their return values. Find gives you the first element that meets your condition, while FindIndex gives you the index of that element. So next time you're working with arrays, consider whether you need the value or the location of your desired element, and choose your function accordingly.
Ever thought about the differences between flat and FlatMap functions in JavaScript? Today, we're going to delve into these two functions, breaking them down to their bare bones and making them easy to understand. Starting off with the flat function. This function creates a new array by merging all subarray elements into it. This merging process happens recursively up to a specified depth. If you're wondering what this depth is, it's an optional parameter that defines how many levels deep a nested array structure should be flattened. The default depth is 1. While the flat function can be a convenient method to flatten arrays, particularly when dealing with nested arrays, it does come with a minor drawback. The depth specification might lead to unexpected results if not set correctly, causing unintended flattening of the array. Next up is the FlatMap function. This function is a bit more complex, as it first maps each element using a mapping function, then flattens the result into a new array. Essentially, it's combining mapping and flattening into one function. The syntax for FlatMap is as follows. The function takes in a callback function, which produces an element of the new array. This callback function takes 3 arguments, the current element being processed, the index of the current element, and the array FlatMap was called upon. There's also an optional thisArg parameter, which can be used to refer to the this keyword in the callback function. If it's omitted, undefined is used. Now, you might be thinking, what's the difference between flat and FlatMap? Well, the flat function only flattens the array, while FlatMap maps and flattens the array in a single step. This makes FlatMap a concise way to both map and flatten arrays, reducing the need for separate steps. However, it might not be suitable for more complex mapping and flattening requirements, as it combines both operations into one function. Let's illustrate this with an example. Imagine we have an array, 1, 2, 5. If we apply the flat function to this array, it flattens the nested array, resulting in 1, 2, 3, 4, 5. However, if we apply the FlatMap function with a callback function that doubles each element, it first doubles each element and then flattens the result into a new array, resulting in 2, 4, 6, 8, 10. In a nutshell, the flat function flattens arrays up to a specified depth, while the FlatMap function maps each element and then flattens the result into a new array. Both functions have their own advantages and disadvantages, and their usage depends on the specific requirements of your JavaScript code.
Ever wondered how to convert iterable objects into arrays in JavaScript? It's a common challenge many face. But fear not, JavaScript has a built-in function named Array.from that comes to the rescue. It's a handy tool that helps create a new array instance from an array-like or iterable object. The syntax for Array.from is straightforward. It takes up to 3 arguments. The first is array-like, which is the array-like or iterable object you want to convert to an array. Then, optionally, you have map_fen, a mapping function that you can call on each element of the array. Lastly, there's thisArg, a value you can use as this when executing the map_fen. What does Array.from undo? It creates a new, shallow-copied array instance from an array-like or iterable object. This function is perfect for converting array-like objects such as nodelist or arguments and iterable objects like set and map into arrays. If a mapping function is provided, it gets called on each element of the array-like or iterable object, and the result is included in the new array. There are several advantages to using Array.from. It can convert iterable objects like set, map, nodelist, and more into arrays with ease. It creates a shallow copy of the array, ensuring that changes made to the new array won't affect the original object. Moreover, it offers flexibility by allowing a mapping function to be applied to each element during the conversion process. However, like all good things, Array.from has its disadvantages too. Using a mapping function or dealing with large iterable objects may introduce performance overhead compared to simpler array creation methods. Also, Array.from might not be supported in older browsers or environments that do not fully support ECMAScript 6. Here's a quick example. Suppose you have a set containing the numbers 1, 2, and 3. To convert this set into an array, you can use Array.from like so, const array equals sign array from set. Now, array is an array with the same elements as the set. Similarly, you can convert a node list of paragraph elements into an array, or you can use a mapping function to create an array of squares from an array of numbers. In summary, Array.from is a powerful utility method in JavaScript, particularly useful when working with iterable objects and converting them into arrays. It provides flexibility with mapping functions, but it's also important to be mindful of potential performance implications, especially when dealing with large data sets.
Have you ever pondered the power and importance of array methods in JavaScript? These methods can save you a lot of time and effort when dealing with arrays, which are ubiquitous in programming. Today, we delve into the world of JavaScript array methods, focusing on three commonly used ones: join, concat, and sort. First up is the join method. This method creates and returns a new string by concatenating all the elements in an array, separated by a specified separator string. The syntax is simple: array.join separator. The separator is optional, and if you leave it out, the array elements will be separated with a comma by default. An example of how to use the join method is as follows. Suppose you have an array of fruits: apple, banana, and orange. If you want to convert this array into a string separated by commas, you would use the code const result equals sign fruits. Join, the output here would be apple, banana, orange. While the join method is a handy way to convert array elements into a string, keep in mind that it modifies the original array. Next, we have the concat method. This method merges two or more arrays, returning a new array with the combined elements of the original arrays. The syntax is array.concat, array1, array2, arrayn. The arrays to be concatenated are optional. Here's an example of concat in action. Let's say you have two arrays, array1 with the elements A, B, and C, and array2 with the elements D, E, and F. To merge these two arrays, you would use the code const result equals sign array1, concat array2. The output would be, the concat method is great for combining arrays without modifying the originals, but remember that it creates a new array, which might consume more memory if used extensively. Finally, let's look at the sort method. This method sorts the elements of an array in place and returns the sorted array. The syntax is array sort compare function. The compare function is optional. If you omit it, the array elements are converted to strings and sorted alphabetically. Here's how you might use the sort method. Suppose you have an array of numbers, 3, 1, and 2. To sort these numbers in ascending order, you would use the code numbers sort A, B equals sign A, B. The output would be. The sort method is versatile and can sort various data types based on custom criteria. However, it modifies the original array in place, so handle with care. In summary, each of these array methods in JavaScript has its unique purpose and use. The join method turns array elements into a single string. The concat method combines arrays without altering the originals. And the sort method arranges array elements in a specified order. Mastering these methods will help you manipulate arrays with greater ease and efficiency. Ever wondered how to perform exponentiation operations in JavaScript in a more concise and straightforward way? Today, the spotlight is on the exponentiation operator, a recent addition to JavaScript introduced in ECMAScript 2016, also known as ES7. This operator provides a more streamlined way to perform exponentiation operations, making it a handy tool for mathematical computations. First, to understand how this operator functions, it's important to grasp its basic syntax. The exponentiation operator is represented by two asterisks, or stars, if you will. It raises the left operand to the power of the right operand. Here's a simple example. If you have a base number, say 4, and want to raise it to the power of 3, you'd write it as 4 asterisk asterisk 3 in JavaScript. Think of the exponentiation operator as a shortcut. Traditionally, you might have used math.pow, or even a series of multiplication operators to achieve the same result. However, the exponentiation operator offers a more concise syntax, improving code readability. For instance, let's consider the following code snippet. Const result =2 asterisk asterisk 3. This is equivalent to 2 raised to the power of 3, or 2 multiplied by itself 3 times. The output would be 8. As you can see, the code is quite straightforward and easy to understand, even for those who might not be familiar with JavaScript. The advantages of the exponentiation operator are numerous. Apart from its concise syntax, it also enhances code readability. When you see the two asterisk symbols, it's clear that an exponentiation operation is taking place. This operator also simplifies your code, especially in mathematical contexts, by reducing the need for additional function calls or manual calculations. However, it's important to note that this operator isn't without its disadvantages. Older browsers and environments may not support the exponentiation operator. This means you might need to use transpilation or polyfills to ensure compatibility. Additionally, there's a learning curve involved for developers who are unfamiliar with the new operator, particularly for those coming from languages that don't have a similar operator. In conclusion, the exponentiation operator in JavaScript offers a concise and clear syntax for performing exponentiation operations. It improves code readability and simplifies mathematical computations. While it does come with its own set of challenges, such as compatibility issues and a potential learning curve, the benefits it brings to the table make it a valuable addition to the JavaScript language. So the next time you're dealing with exponentiation operations, consider using the exponentiation operator for a more efficient and readable code.
Ever grappled with the challenge of working with objects in JavaScript before the advent of ECMAScript 2017, commonly known as ES8? Remember those times when extracting values or iterating over the properties of an object seemed like a daunting task? Well, those days are a distant memory now, thanks to two static methods introduced in ES8, Object.values and Object.entries. Firstly, let's delve into Object.values. This handy method does the heavy lifting for you by returning an array that contains the values of an object's innumerable properties. The syntax couldn't be simpler. Just type Object.values and pass in the object you're working with. For instance, consider an object defined as follows: const object =a, 1, b, 2, c, 3. To get an array of the object's values, we'd write const values =, object.values obj. Upon logging values to the console, you'll see an array. Now let's move on to the second method, Object.entries. This method takes it a step further by returning an array containing arrays of key-value pairs for each enumerable property in an object. The syntax is very similar to Object.values. Simply use Object.entries and pass in the object. For the same object we used earlier, applying Object.entries obj yields. This can be extremely useful for tasks like iterating over object properties or converting object properties into arrays for further processing or manipulation. But what makes these methods so transformative for JavaScript developers? The primary advantage lies in the convenience they offer. They simplify tasks that were once complicated, such as extracting values or iterating over object properties. Moreover, they provide a consistent way to handle object properties, aligning with other methods like object.keys. This consistency is a key aspect of making the language more intuitive and easier to use. In terms of compatibility, Object.values and Object.entries are widely supported in modern browsers and Node.js environments. If you're working in an older environment, you might need to use polyfills or transpile your code, but that's a small price to pay for the convenience these methods offer. To sum up, Object.values and Object.entries are powerful tools in the JavaScript standard library. They offer convenient ways to work with object data structures, making tasks like iterating over object properties, converting object properties into arrays, or even checking for the presence of specific values or key value pairs in an object a breeze. So, the next time you're faced with the challenge of working with objects in JavaScript, remember these methods. They're here to make your life easier.
Have you ever wondered how to ensure consistent string lengths in JavaScript? String padding might just be the solution you're looking for. This technique involves adding characters to the beginning or end of a string until it reaches a certain length. This proves particularly useful when you need strings to maintain a consistent length, like when formatting dates or numbers. The ES8 or ES 2017 version of JavaScript introduced two methods to facilitate string padding: padStart and padEnd. The syntax is straightforward. For padStart, you write your string, followed by a padStart target length. Similarly, for padEnd, you write your string, followed by padEnd target length. The str stands for the original string, while target length represents the desired length of the resulting string after padding. Pad string is optional and represents the string to pad with. If not provided, the default is a space. Let's illustrate this with an example. Suppose we have a string 5. If we use the padStart method with a target length of 2 and a pad string of 0, our output becomes 05. On the other hand, if we use the padEnd method with the same target length and pad string, our output becomes 50. What's the difference between these two methods? Well, padStart adds padding characters to the start of the string, while padEnd adds them to the end. String padding comes with a host of advantages. It ensures consistent formatting, which is useful for aligning text or numbers in tables, file outputs, and so on. It also simplifies the generation of fixed-width strings without the need for complex logic. However, like all good things, string padding should be used in moderation. Overuse can lead to excessive string length and unnecessary memory consumption. In summary, string padding in JavaScript, courtesy of padStart and padEnd methods, offers a convenient way to ensure consistent string lengths. It's a handy tool for formatting output, aligning text, and simplifying string manipulation tasks. But remember to use it judiciously to avoid bloating your string lengths unnecessarily. So next time you find yourself needing strings of a consistent length, consider giving string padding a try. You might find it's exactly what you've been looking for.